like to take the roll call for the panel members. And I will begin with the panel members who are in person. Dr. Peter Fong.
Present.
Dr. Aaron Bachowski.
Present.
Dr. Hugh Barton.
Present.
Dr. Eamon Chan.
Present.
Dr. Wei Chun Chow.
Present.
Dr. Matthew Gribble.
Present.
Dr. Margaret Carrigas.
Present.
Dr. Michael Pennell.
Present.
Dr. Gloria Post.
Present.
Dr. Christopher Stace.
Present.
Dr. Danielle Wilcock.
Present.
Dr. Carol Wood.
Present.
Thank you. And now we'll go to the panel members who join us remotely. Dr. Mark Bosso. Dr. Mark Bosso. Dr. Sylvie Broder. Dr. Sylvie Broder. Dr. Arno Navis Asian.
Present, yes, here.
Thank you. Dr. Isaac Pesak.
Here.
Thank you. So we are missing two. Maybe they will join us later. Good morning. I am Dr. Diana Wong, and I'm the Designated Federal Officer, or DFO, for the Science Advisory Board, SAB, Inorganic Arsenic Review Panel. In my role as a DFO, I would like to formally open this public meeting of the Inorganic Arsenic Review Panel. The purpose of this meeting is for the SAB Inorganic Arsenic Review Panel to review the draft IRIS toxicological review of inorganic arsenic, to receive briefings from the senior EPA officials on the draft document, request clarifications of any materials shared, and to deliberate on responses to the charge question, and allow the public an opportunity to provide public comments to the technical document. The SAB is an independent, expert Federal Advisory Committee chartered under the authority of the Federal Advisory Committee Act, or FACA. The SAB is empowered by law, the Environmental Research, Development, and Demonstration Authorization Act, to provide advice to the EPA administrator on scientific and technical underpinnings of the EPA's decision. FACA and EPA policy require that SAB meetings be announced to the public in the Federal Register, and that substantive deliberations and interactions with EPA and the public be conducted in open sections where DFO is present to ensure that the requirements of FACA are met. FACA also requires that public meetings provide an opportunity for oral and written public comments. There is a public comment period noted on the agenda for this meeting, where members of the public can register in advance with the SAB staff office to make oral comments. We have 10 registered public speakers for today. They will have 5 minutes each to speak. There is also another opportunity for the public to provide 2-minute clarifying comments on the last day towards the end of the meeting. Members of the public who want to provide clarifying comments on the last day can register with me either at the meeting or send me an email. My email address is wong.diana-m@epa.gov. All public comments were distributed to panel members, and they have been asked to take them into consideration as they respond to their charge questions. Public comments are available on the SAB website, along with all the other meeting materials. pertaining to these advisory activities. Minutes will be prepared to summarize discussions and action items in accordance with requirement of FACR. The SAB staff office will work with the panel chair to have the official minutes certified so they can be posted on the SAB website. The SAB consists entirely of special government employees appointed by EPA to their positions. As government employees, all the members are subject to all applicable ethics laws and implementing regulations. The SAB staff office has also reviewed other information related to the public statements expressed by experts on this panel related to the advisory activity under consideration. EPA has determined that the advisors participating in this meeting have no financial conflicts of interest or appearance of lack of impartiality under ethic regulation related to the topic of this meeting. Now, I would like to turn the meeting over to Mr. Tom Brennan, the Director of SAB Staff Office, to give his welcoming remarks.
Thank you, Diana, and thank you for all the work as DFO that you're doing for this panel. I already addressed this group in our public meeting for the Zoom call, so I'll just keep it brief and just reiterate. Thank you to the panel members for your public service. On behalf of EPA, I'd like to say that we really appreciate you taking time out of your professional lives and personal lives to help us with this activity. I'd also like to thank my EPA colleagues in ORD who worked so hard over so many years to deliver this material for peer review. It was a big effort, and I congratulate them on that. I'd like to thank members of the public who have been taking advantage of public comment periods, both written and oral, to contribute to this activity. So thank you to them. And finally, to the SAB staff office and our contractors, you all are a great team and really make these meetings happen. So I appreciate you all very much. And with that, I'll turn it over to Dr. Thorne to take it away.
All right. Good morning, everyone. I'm really happy to be at this point of the day and this meeting. It's been quite a ride in the last couple of weeks for our panel members, working very diligently to quickly assemble all this information. And we've been getting a lot of robust public comment coming in very quickly. And so I think, I appreciate all the work that you have all put forward towards this end. I just want to, before I get into the agenda items, make one housekeeping suggestion, and that is that if you wish to speak, you just set your tent up on edge like this, and then I'll know to call on you. And I'll try to watch the order in which those go up. I may not always get it right, but that's an easy way for people in the room to let me know that they want to speak. And people online, I'll watch for you and just hopefully not neglect you. I'll watch for a hand up, or I'll have help to indicate that you want to speak. But if you want to speak and you feel like you're not being called upon, just make sure and butt in, because we want to make sure we hear from you too. I know it's always difficult to participate online in a room that's primarily in a meeting that's primarily in a room here. So with that, I just want to quickly go around the table and online and have people introduce themselves. We did this in our last meeting, so let's just go with sort of your name, your professional title, and your affiliation. The expertise that you all bring will be coming out and obvious in the discussions we have today. So, so let's just start with Aaron Burkowski.
Hello, I'm Aaron Barchowski. I'm a professor of environmental and occupational health at the University of Pittsburgh. And I have over 30 years of experience in mechanistic research investigating how arsenic causes cardiovascular and metabolic disease.
Okay, thank you. Hugh Barton.
I'm Hugh Barton. I'm an independent consultant, retired from Pfizer and the US EPA with experience in pharmacokinetic and pharmacodynamic modeling.
Okay, Dr. Mark Borsick, online.
Hi, I'm Mark Borsick. I'm a professor in the Department of Civil and Environmental Engineering at Duke University. I'm also co-director of the Duke Center on Risk.
Thank you. I don't think Sylvie Boudère has joined us yet. No. Okay. Dr. Eamon Chen.
I'm in Chen. I'm professor of epidemiology in the Department of Biostatistics, Epidemiology, and Informatics in Permanent School of Medicine, University of Pennsylvania. I do research in children's environmental health, mostly on metals and endocrine disrupting chemicals.
Thank you. Dr. Wei Chung Cho.
Hello, everyone. My name is Wei Junzhou. I'm assistant professor in the University of California, Riverside at Department of Environmental Sciences. My expertise is development of PPK model in assisted risk assessment. Thank you.
Okay. Dr. Matt Gribble.
Hello, my name is Matthew Gribble. I am an associate professor of medicine at University of California, San Francisco. I'm also the associate chief for research in occupational, environmental, and climate medicine. And I bring expertise as an environmental epidemiologist who's worked on arsenic for over a decade, as well as a diplomat of the American Board of Toxicology.
Okay. Thank you. Dr. Margaret Carrigas.
Good morning. My name's Margaret Carrigas. I'm professor and chair of the Department of Epidemiology at the Geisel School of Medicine at Dartmouth. And I have decades of experience conducting epidemiologic studies on arsenic.
Thank you. And online, Dr. Ana Navas Asian.
Good morning, everybody. I am Ana Navas Asian. I am a professor of environmental health sciences at Columbia University. I am an environmental epidemiologist by training, and I've been doing involved in arsenic epidemiological research and others for 20 years now. So it's an honor to be here. Thank you.
Thank you. Dr. Michael Pennell.
Hi, I'm Michael Pennell. I'm Associate Professor of Biostatistics at Ohio State University. My expertise is in Bayesian non-parametric methods, a lot of which is applied to tox risk assessment.
Thank you. And online, Dr. Isaac Pessa.
Good morning, Isaac Pessa here. I'm professor of neurotoxicology at the University of California, Davis. And my specialty is molecular and cellular mechanisms of neurotoxic processes.
Thank you. Dr. Gloria Post.
Good morning. I'm Gloria Post. I'm a research scientist in the New Jersey Department of Environmental Protection, Division of Science and Research. I'm a human health toxicologist, and I have expertise in human health risk assessment.
Okay, Dr. Christopher States.
Hi, I'm Christopher States. I'm a professor of pharmacology and toxicology and director of the Center for Integrative Environmental Health Sciences at the University of Louisville School of Medicine. My expertise is in molecular mechanisms of arsenic carcinogenesis.
Dr. Danielle Wyckoff.
Hi, good morning. Danielle Wyckoff. I'm the Chief Scientific Officer at Tox Strategies. I'm a toxicologist and risk assessor and have been practicing research with using systematic review methods to support risk assessment.
Okay, Dr. Carol Wood.
Dr. Carol Wood, retired from Oak Ridge National Laboratory, doing human health risk assessment, emergency planning, emergency response.
Okay, thank you all. And I'm Peter Thorne. I'm University of Iowa Distinguished Chair and Professor in the Department of Occupational Environmental Health in the College of Public Health. Okay, so I'd like to just quickly review the agenda, and it's pretty straightforward, although it's 3 days long. So we're going to first hear this morning opening remarks from EPA, and then we'll have a presentation on the document that's before us that we've been working on from Dr. Janice Lee and Dr. Alan Davis. We'll have an opportunity then to ask them clarifying questions. This is scheduled with 30 minutes, but if it goes a little long, we can go long on that one if we need to. Then we get to hear from the public, and we have 10 public speakers signed up to present to us, and they'll each have 5 minutes, and this is a great opportunity to hear from them. They've submitted written comments as well, which we have received as recently as last night. So we have those to look at as well. After lunch, then we'll dive into the discussion of draft responses to the charge questions that we have been working on so diligently. And then we'll just step through those over the next several days. And you see on the agenda 1, 2A, 2B, et cetera. The primary or lead discussant will lead off, and then the other people who've worked on that charge question will have the opportunity to add in on that or offer their comments in addition. And then we'll open it to the panel as a whole if anybody else on the panel has issues that they want to bring forward. And then at the Friday period of time, we'll each morning I'll try to kind of summarize where we are from the day before. But when we get to Friday afternoon and have completed our discussion of charge question 9, we have another opportunity to have clarifying comments from the public. And so that will be scheduled currently for 4:20. And although we have a rigid agenda in terms of the timing, we can flex this a bit. In meetings like this, it's very common that the early discussions take longer than the later discussions because we air many of the issues early on, or we just get more efficient. So I'll manage the agenda as best I can, and hopefully we'll come out with all the time we need to do a very careful discussion of each of these charge questions. So I think that we are at time here we're even a little ahead of schedule. That's always a good sign to receive some opening remarks from EPA. And first we have Dr. Maureen Gwynn, who's the Chief Scientist and EPA Principal Deputy Assistant Administrator of ORD.
Thank you for setting up. There we go. Good morning, everyone. Thank you for having me here today. As Dr. Thorne said, I am Dr. Maureen Gwynn. I'm the Principal Deputy Assistant Administrator for the Office of Research and Development, getting my technology in place. And I'm also the Chief Scientist for the US EPA. Really excited to be here. For those of you who don't know me, I started my life at EPA in the IRIS program. And so I'm very familiar with the process and the work that goes into, on the EPA side, the work that we have to do to develop these documents, but also the feedback we get from all of you and the importance of peer review. I don't think I have to tell anyone in this room how important that is to our process. And, you know, all the parts that get us to not only today, but to move these documents forward, to post them for the final posting and for support and of the EPA mission of protecting public health and the environment. So I'm just going to say a few words. Unfortunately, I can't stay here all day today or through Friday. Dr. Thorne, even though you made it sound so appealing to be here, but I know you're in good hands with the EPA team and the SAB team here. So as you all know, EPA's mandate is protecting human health and the environment, and we do that through science-based decision-making. ORD's role, or Office of Research and Development, is to provide that scientific foundation for that decision-making. Our agency conducts risk assessments and risk management activities under a variety of mandates. Again, I think many of you are very much aware of that on different levels. Our environmental statutes across the different program offices may vary, and ORD's role provides that hazard identification and dose response assessments to inform those chemical risk assessments. So one example of this is EPA's IRIS assessments. I think, again, everyone in the room is probably very familiar with the IRIS assessments. These are our top tier source of human health hazard information, and they're recognized as a gold standard for hazard identification and dose response assessments. These are developed in accordance with agency guidelines and procedures, and including in that the policies for scientific integrity, quality assurance, and peer review. As the agency's chief scientist and the senior career leader in ORD, I'm really proud of the accomplishments made thus far by the IRIS program and the work to evaluate and characterize the research and methodologies underpinning this draft assessment. I can't speak highly enough of the team that is here today and that has worked on this assessment for you all. And I know, again, you're in good hands when I have to step out for them to address any of your questions. They have been able to build on the strong science and methods that have been incorporating input throughout the assessments development process. And it's great to see us arrive here today. I know I had mentioned earlier as we were mingling prior, which not only great to see everybody in person, but be able to just have some conversations and just what a milestone this is for the program, for the team, and for the agency. So I am looking forward to hearing about the committee's deliberations and seeing the SAB report in the future. And I want to second Tom Brennan's comments and thanks to the panel that's here today, the SAB staff for getting us to this point, the EPA team that has pulled this assessment together over more years than we probably want to count, and also to the public for your interest in this assessment and in making sure EPA does the best science, the most defensible science for this important work. So I will stop there. And again, thank everybody. I will try and sneak out and not be too disruptive when I go, and I will hand it off to Dr. Chris Thayer. So
Okay, thank you. Well, let me introduce Dr. Chris Thayer, who is Division Director, Chemical and Pollutant Assessment Division at ORD. And we're pleased to have you here, Dr. Thayer.
Well, thank you. So I also just wanted to sort of thank the SAB staff and the contractors for organizing this. It's no small feat to organize a review like this, and so we very much appreciate your dedication and patience. And I also wanted to echo your Tom's appreciation to the panel for your service, for the work that you've already done and that will continue to do. You have many people sort of listening to your every word. And then also to people who are in the audience, either in person or online, whether you're an observer or whether you've provided written and or oral comments, I think your engagement is really testament to the importance of this assessment. And I think we all realize that. I don't really have much in terms of, I want to give a little bit of context for the presentation that you're going to hear from Alan Davis and Janice Lee. And so on January 5th, we had a pre-meeting meeting. And there was a slide presentation that really kind of summarized the assessment. And then following that, there were a number of topics that came up in terms of clarification. So what we're trying to do today is that we may sort of remind people of some of sort of the major decisions made in the assessment, but it's really more to try to focus more on those topics of clarification. And I wouldn't be surprised if there were other clarifying questions that came up. So in the audience, you have many members of the Arsenic team. Others are online. So we're available to you. And that also includes if you have questions about where content might live in the assessment. When you have a main document and different supplemental appendix files, and it can be challenging to understand where certain content might live. So again, we're here. And with that, I'm going to go ahead and pass it off to Janice Lee and Alan Davis.
We're co-chemical managers of the Chemical and Pollutant Assessment Division. So thank you for being here today to present to us again.
Getting our name tags. All right, good morning. Before I start, I also wanted to thank the SAB panel for your time and efforts. And so as Chris mentioned, what we want to do today in this presentation is to provide a recap and also provide some clarifications on select topics. Next slide. Okay, and this is a slide that you've already seen before. This figure shows the IRIS assessment development process, which is a 7-step process. Step 1 involves scoping and problem formulation prior to draft development. And after the draft is developed, it then goes through the review steps, starting with agency review, followed by interagency review. The draft is then released for public review and comment and external peer review, which is the step that we're currently at for this assessment. After step 4, the draft is then revised based on comments received from external peer review and the public. Following that, there's a final agency review and interagency science discussion. And then the assessment is finalized and posted to the IRIS website. During this process, there are opportunities for the public to engage, and this is highlighted in the tan boxes. So early in step 1, there's a public meeting to discuss what the assessment will cover. For inorganic arsenic, EPA held a public planning and scoping workshop. Then in the middle of step 1, the protocol was released for public comment. And in step 4, assessment materials were released for a 60-day public comment period.
Okay, next slide. So to recap, IRIS assessments are systematic reviews of publicly available scientific studies on environmental agents. And Maureen Nguyen already touched on this, but this figure shows the risk assessment paradigm and how IRIS assessments include both qualitative and quantitative information. It includes hazard identification and dose response assessment, which are the first two steps of risk assessment shown here in the green boxes. The remaining steps in blue that include exposure assessment, risk characterization, and risk management are actions performed by other EPA programs and regions where IRIS assessments are used to inform their activities and decisions. Next slide. As I mentioned earlier, the IRIS 7-step process includes opportunities for public comments. So here what I wanted to do is summarize the multiple public opportunities for engagement that have occurred during development of this assessment. Starting in 2012, EPA released problem formulation materials for public comment. In 2013, EPA hosted a workshop to discuss planning and scoping. And that same year, EPA also hosted a webinar series where outside speakers were invited to present on different topics like exposure, mode of action, neurodevelopmental effects in children, and hypertension. In 2014, EPA hosted a public science meeting on the preliminary materials. And then in 2019, EPA released the updated problem formulation and protocol for public comment. And then the NAS hosted a public meeting to evaluate that document. And more recently, the draft assessment, model code, and modeling results were released for public comments. And public comments are available in the docket, and EPA has collated and summarized all the public comments. So now I wanted to recap the major elements in scoping and problem formulation. A decision was made to focus on human data for dose response. And this is consistent with NRC's conclusion that human data are expected to be the basis for dose response analyses. By using human data, uncertainty related to species extrapolation and relevance can be avoided. And it also allows for observations in human variability. The decision to focus on human data is also consistent with recommendations in EPA guidelines and the NRC NASEM external reports on inorganic arsenic that stated human data is preferred over animal data when there are epidemiologic studies of sufficient quantity available. A significant amount of work was done to look at the potential use of mode of action analyses to inform dose response. And this approach was supported during the 2019 NASEM peer review of the protocol. And this is currently presented in Appendix A of the updated problem formulation and protocol document, which includes an analysis of the modes of action listed here in this slide. During this analysis, almost 6,000 studies were screened and close to 200 studies were summarized. In addition to that analysis, we also conducted a case study using bladder cancer to look at the feasibility of using mode of action and mechanistic data to inform dose response. And what we found is that using mode of action for the inorganic arsenic assessment would introduce uncertainty. And this is because in vitro studies are conducted at higher concentrations. In vitro model systems would have to be applied to humans. Also, can in vitro concentrations be extrapolated to human exposure levels? And then there's also difficulty from extrapolating from rodent studies since humans are more sensitive to animals, or humans are more sensitive to arsenic. Ultimately, the mode of action analyses were not considered more suitable than the epidemiology studies. And our mode of action approach adheres to EPA's cancer guidelines, which states that mode of action analyses are used to address human relevance, human variability, and to inform dose response. The guideline recommendations are typically applied to chemicals where human evidence is insufficient or human relevance needs to be established. So when we look at how this applies to arsenic, starting with human relevance, inorganic arsenic is a known carcinogen with a large amount of high quality epidemiology evidence. For human variability, there's also extensive information on risk modifiers and susceptibility in a number of epidemiology studies. And then for dose response, there are epidemiology studies with low-level exposure to inorganic arsenic, which means that we do not need to extrapolate to low dose. Okay. And then this slide summarizes the non-cancer and cancer health effects evaluated and hazard conclusions. Non-cancer effects evaluated include effects on the circulatory system, diabetes, pregnancy, and birth outcomes, and neurodevelopmental effects. The currently available evidence demonstrates that inorganic arsenic causes diseases of the circulatory system and diabetes in humans, and the evidence indicates that inorganic arsenic causes pregnancy and birth outcomes and neurodevelopmental effects in humans. Since cancer effects are well established, we adopted a classification of human carcinogen for bladder cancer and lung cancer. So hazard identification here was not revisited. And for cancer, the focus was on dose response analysis. In this red box are other outcomes that were considered to be out of scope for the assessment. And this includes skin cancer, skin lesions, and immune effects. This was determined based on a relative risk over the background exposure screening analysis. And then for renal cancer, liver cancer, and non-malignant respiratory, these were considered out of scope and not considered further based on moderate evidence base, and there wasn't a benefit cost need. Okay, so with that, I'll turn it over to Alan.
Thanks, Janice. And I'd just like to, thank the SAB panel for your work so far and the hard work to come over the 3 days and when you write your report. So wanted to provide just some clarifying presentation on the dose response methods used in the assessment and drill down into some topics that were some questions were asked. So just wanted to recapitulate that the dose response approach used in the arsenic assessment is fully described in the 2 Allen et al. 2020 papers and completely recapitulated in Appendix C. And the workflow for the dose response can, the graphic to the right here, is useful in sort of conceptualizing the approach. There were some pre-analysis steps that we conducted in order to calculate effective counts for our dose response. So taking the adjusted odds ratios or relative risk values from the epi studies that we included in the analysis and calculating incidence data or incidence values that retain the control for confounding that was conducted in the studies. A probabilistic approach to convert study-specific dose metrics to our unified dose metric of daily intake. That gave us our dose information. It gave us our response information that then went into the hierarchical Bayesian analysis, where we use the logistic model to model the individual studies, but also to estimate a pooled estimate of arsenic on the endpoint being modeled. And then that logistic slope was then fed into our life table analysis, where we generate our lifetime extra risks. Next slide. So I guess first step in the pre-analysis is, we wanted to include as many studies in our dose response meta-analysis as possible. And so previous meta-analyses or dose response analyses had focused on studies that reported arsenic exposure in micrograms per liter, so drinking water studies. But we wanted to broaden the scope and include studies, urinary biomarker studies, or studies that used other exposure metrics that might be more appropriate, like cumulative exposure, and then convert all those study-specific metrics into, again, a unified daily intake value in units of microgram per kilogram day. And so what we did was first identify exposure factors that were necessary for the conversion. And we had a hierarchy of preference. So we preferentially wanted to identify exposure factors that were sourced from the paper. So if we needed a measure of dietary intake and the study reported dietary intake, that's the value we used. If it was missing in the study, we would step back and look, well, has this cohort been used in other studies? Did those studies report this exposure factor? If that wasn't the case, then we would try to use exposure factor relevant to the nation that the study population came from, so a Taiwanese specific exposure factor. And then barring that, we would use a value like source from the EPA exposure factor handbooks. And so, for example, for a study reporting cumulative exposure in units of microgram liter per year or times a year, we would use this equation. We would source, the exposure factors, dietary intake, water consumption rate, water concentration, like a measure of low-end water concentration to represent a time period that the study participant wasn't in the arsenic, the high arsenic area. And next slide. And then we would infer probability distributions for each conversion factor. And those parameters were based on the reported means and standard deviations. We would conduct a Monte Carlo analysis where we would sample those distributions in number of times, where n equals the study-specific dose group size. We would average those individual daily intakes for that dose group. And then we would repeat that process 1,000 times to generate a final MC distribution where we used the 5th percentile, the mean, or the 95th percentile daily intake values for our subsequent dose response analyses. Next slide. For the urinary biomarker studies, we used the El Masri and Kenyon 2018 PBK model to provide the basis for an assumption that a 1-to-1 ratio between inorganic arsenic oral intake and total arsenic daily urinary excretion existed. So we didn't run the PBK model as you would in a assessment where we would have the like an external concentration where we wanted to calculate an internal concentration. We would run the PBK model and it would output the internal metric of interest. We used the conclusions of the PBK paper that demonstrated this 1-to-1 ratio. We assumed that the urinary levels came from arsenic intake from drinking water that did vary across the exposure groups, and then used a study-specific estimate of dietary intake that was consistent across the exposure groups. Next slide. And then like for the conversion of other metrics into the daily intake, we used the following equation that was sourced from Forney Agna 2015 and also the El Masri Kenyon 2018 paper in order to do that conversion. And so we used the exposure factors for height, body weight, age, sex, and total arsenic urinary excretion to do that conversion in order to calculate the daily intake metric in units of microgram per kilogram day, and then conducted an MC analysis similarly to the conversion of other exposure metrics to finally arrive at the daily intake value that was used in the following dose response analyses. Next slide. For the Bayesian dose response meta-analysis, which we have called a meta-regression in the assessment, the main purpose was to combine data from multiple cohort and case control studies, and we wanted to do it in a statistically rigorous manner that other meta-analyses in the past had either focused on all case control studies or all cohort studies, or they had modeled odds ratios and relative risks as continuous variables based on a assumption that that was appropriate given diseases that have low prevalence. But In the case of some of the non-cancer endpoints that we are modeling, DCS, diabetes, they are highly prevalent in the US population and have a high lifetime probability. And so that simplifying assumption might not be appropriate. So we assumed that the prospective likelihood was given by a logistic equation with arsenic as the explanatory variable. And this allowed for the estimation of the prospective likelihood from case control studies, which are retrospective by definition, and thus allowed their inclusion with cohort studies in a dose response meta-analysis. We used the logistic model to do that. The logistic model is flexible enough to represent nonlinear sigmoidal dose response relationships that are expected at a population level for toxicants that have widely different individual sensitivities. That might be due for a number of reasons, human heterogeneity or multiple modes of action that are operant. And this type of sigmoidal shape is possible at a population level, even if the dose response relationship has a clear threshold in a single rodent species or cell line, and that's consistent with previous NRC conclusions. Next slide. The priors that we used for the hierarchical Bayesian modeling was for the individual studies. We allow a normal distribution for individual studies. That does allow for negative logistic slopes. And that's in recognition that study-specific characteristics and just if a study had low N or other characteristics that might obscure the observation of a positive association, we wanted to account for that. So we do allow for the normal distribution and negative slopes for individual studies, but for the pooled slope, in order to be consistent with our HI determination, we used a gamma distribution for the pooled logistic slope, and that does not allow for negative values. Priors that we used for the analysis are in the table below the text. And then the output of the modeling is a set of study-specific logistic slopes and a pooled estimate of the logistic slope, and the graphic in the table to the right demonstrate what's output by the model. Next slide. And then for the life table analysis, where we had the data available, we used age stratified morbidity and mortality data to calculate a lifetime probability of disease at our assumed background dose. For CVD incidence and IHD incidence and diabetes, we don't have age stratified data, and so we had to use a single value of the lifetime probability. But the life table was conducted in a similar manner, even though it was more approximate. So in the all the individual lifetime or life table analysis spreadsheets, we would manually enter the 5th percentile, the mean, and the 95th percentile of the individual study slopes and the pooled slope. And then the life table would estimate the lifetime probability of disease given those logistic slopes, and then we calculate those lifetime extra risks over a range of hypothetical doses that we selected to represent the full range of low dose and high dose exposures that might be expected in an exposed population. And then lifetime extra risk was calculated with the standard extra risk equation there. Next slide. And so just to go over the individual endpoint results for bladder cancer, like Janice said, we just accepted the determination of carcinogenic to humans. There were 11 epidemiologic studies that we used in the dose response meta-analysis, and then the output of all the life table analyses are recapitulated in these tables throughout the dose response section, where we collate all of the lifetime extra risks in a single table. And so, for example, for bladder cancer here at 0.13 micrograms per kilogram day, which is the daily intake that is at the current drinking water standard, the mean lifetime extra risk that we calculated is 7.85 extra cases, or 7.85, 7.85 times 10 to the negative fourth lifetime extra risk. We take those numeric values, we then plot them in the dose response section and fit polynomial or linear trend lines to those lifetime extra risks. For the cancer endpoints in the low dose range, we observed that the relationship was approximately linear. So we provide a slope for the 95% lifetime extra risk values and present that as the cancer slope factor. It should be noted that throughout the document, we do refer to the lifetime extra risks that are calculated in the text. And then we refer to the cancer slope factors. The cancer slope factor is the slope of the 95% values, whereas when we report lifetime extra risks, we are typically discussing the mean values. And so that is just a nuance that needs to be considered when reading the results in the assessment. Next slide. Lung cancer, same approach, present the lifetime extra risks at a number of doses tabularly, present them graphically as well, and then present the slope of the 95% lifetime extra risks as the cancer slope factor. Next slide. We provide a combined cancer slope factor to estimate the risk of developing either bladder cancer or lung cancer separately or both cancers combined. And this is an approach that is consistent with previous NAS and NRC recommendations, and the method that we used to calculate the combined cancer slope factor has been used in previous IRIS assessments as well. And so the final cancer slope factor presented is 5.3 times 10 to the negative 2. Next slide. For non-cancer dose response analyses, again, where possible, we used the same approach for the non-cancer endpoints as we did for the cancer endpoints, where we apply the Bayesian dose response meta-analysis. For diseases of the circulatory system, we model 4 endpoints actually. So cardiovascular disease incidence and fatal CVD, and then ischemic heart disease incidence and fatal IHD. For the 2 incidence versions of those endpoints in the dose response meta-analysis, we model 2 endpoints for CVD incidence and 4 endpoints for IHD incidence. For diabetes, we model it with the Bayesian dose response meta-analysis approach. We use 4 studies. For pregnancy outcomes, we had to take a different approach. The majority of the pregnancy studies or developmental studies we had reported their exposure metrics. They were biomarker studies where the exposure was either characterized in maternal urine or cord blood. And the association that the El-Masri and Kenyon paper showed, a one-to-one relationship, we weren't confident in assuming that for pregnant women, given that PBK model was not parameterized for pregnant women. So we were constrained there to look at studies that reported their exposure metric as drinking water concentrations. And so we found one study that we could use, the Kyle et al. 2016 study. And so we carried that study forward as the critical study for pregnancy outcomes. And then for neurodevelopmental effects, we looked at a number of studies, ultimately focusing on the Wasserman et al. 2004 and 2014 studies, ultimately selecting or focusing on the Wasserman et al. 2014 study, but ultimately decided not to advance that study for point of departure derivation given non-monotonicity in the exposure response relationship. And that analysis is described in Appendix C.2. Next slide. So for DCS endpoints and diabetes endpoints, the next 2 slides are going to look, almost identical to the bladder cancer and lung cancer slides, where we calculate lifetime extra risks at a number of doses. We plot those. We provide polynomial trend lines to the data, and then manually, just to orient users to how these lifetime extra risks compare to the BMDL that we calculate in the RFD section, we manually add the BMD value and the BMR value. So the BMR value being the horizontal orange line, the BMD value being the vertical orange line. But it shouldn't be confused that these plots don't represent BMD modeling. The points on these plots are the lifetime extra risks that are output from the combination of the hierarchical Bayesian modeling and the life table analysis. They themselves were not entered into BMDS or any other dose response software and used to derive the BMD and the BMDL. Those were derived in a separate fashion that I'll go over in a couple of slides. So just want to make sure there was no confusion that these represented the output of, the plots you would see that would be output from BMDS. Next slide. Same thing for diabetes. I mean, we're used to these by now, I hope. The tabular presentation of lifetime extra risks over a range of doses, and then graphic presentation with polynomial trend lines fit to that lifetime extra risks. Next slide. So at this point for non-cancer and cancer endpoints, we have applied a identical dose response approach with extrapolation to our target population of the United States population. We've provided lifetime extra risk values over a range of doses that we selected just for results presentation. But the life tables are available to end users of the assessment. So if they are interested in a dose that we didn't select, they can go back and calculate an exact lifetime extra risk at that value. We've provided approximate trend lines so people can, if they don't want to run the spreadsheet themselves, they can calculate an approximate lifetime extra risk at any dose of interest. And so we've harmonized the methods to the degree that we could at this point between cancer and non-cancer. But in addition to that, to meet the needs of our stakeholders, we have also presented more traditional dose response values, the cancer slope factors for the cancer values, and then the calculation of reference doses that I'll go over in a second. And just to orient everybody again to the definition of the RFD, it's an estimate with uncertainty spanning perhaps an order of magnitude of a daily oral exposure to the human population, including sensitive subgroups, that is likely to be without an appreciable risk of deleterious effects during a lifetime. So it's not a value where there's no risk, it's just likely to be without an appreciable risk. And I should note something I should have said for the presentation of the Bayesian results and the lifetime extra risks. All of the lifetime extra risks are calculated from a hypothetical 0 exposure to arsenic, which doesn't exist in the real world, but cancer slope factors and RFDs are typically calculated from a point of no exposure. And so we presented our lifetime extra risks from that hypothetical 0 exposure. So we wanted to be clear about that. Next slide. So for the RFD derivation, instead of going back and modeling the data, with BMDS or using a traditional BMD method, we wanted to leverage the modeling that we had already done. So for the non-cancer endpoints for which we derive RFDs, except for birth weight, which I'll go over in a second, we take the lifetime background rate of disease that we assume. And so for CVD incidence, it's 70%. And the assumed background exposure, which we calculated to be 0.0365 micrograms per kilogram day. We use the logistic slope that came out of the Bayesian modeling, which for CVD incidence is 0.23, and calculate the probability of response at 0 dose. And that was estimated to be 0.698. And so that's P0, which you'll see in an extra risk equation. Then used selected a BMR for the RFD derivation. We used an extra risk of 5%. We felt that the typical BMR of 10% was not warranted given that we were modeling epi data, but Also, that a BMR of 1% was not appropriate, given that, you know, CVD incidence, diabetes, IHD incidence are not, you know, what we consider to be frank effects like mortality or, you know, other endpoints like that. So we used a BMR 5% estimated P of D as 0.713. We calculate the odds for each of those values and take the ratio of those odds. And then the BMD is the natural logarithm of those odds divided by the logistic slope. The BMDL is that same calculation, but instead of using the central estimate for the logistic slope, we use the 95th percent lower bound on the slope. And this is if you use the life table analysis and sort of flipped it, so instead of calculating risk at a dose and calculated dose at a risk, it would give you this same result. But that would it's a little bit more complicated to do that. You have to use the solver function in Excel, given the way we've set up the spreadsheet. So we did this more manual calculation to arrive at the same value. Next slide. For birth weight, again, we couldn't use the Bayesian dose response meta-analysis approach. We were restricted to a study that reported their exposure as micrograms per liter in drinking water. So we used the Kyle study, and using a single critical study is consistent with IRIS approaches in the past. A lot of IRIS assessments focus on identifying a critical study and a critical endpoint from that study. So, you know, the arsenic exposure the arsenic assessment, excuse me, uses a meta-analysis approach where possible, but then, you know, in this case, we're defaulting back to a approach more consistent with, you know, previous IRIS assessments. So the Kyle assessment, or sorry, the Kyle study reports linear regression coefficient for the association between inorganic arsenic exposure and low birth weight in terms of per natural logarithm of micrograms per liter arsenic in drinking water. We re-expressed that to be in terms, that regression coefficient to be in terms of just per microgram per liter inorganic arsenic. Birth weight is a endpoint for which there is a adversity cutoff, a clinical definition of what adversity is. So that gave us the opportunity to use the hybrid approach for defining the BMR. We looked to the CDC natality file, so all the births in the United States for 2018, I believe. We were able to calculate the mean birth weight, the standard deviation for that birth weight, and then the percentage of those births falling below that clinical definition of birth weight. And then we defined the BMR as 5% extra risk of falling below that cutoff. And so ultimately we were looking for the dose that resulted in, I think, 12.3% of the population falling below that adversity cutoff of 2,500 grams birth weight. Rearranged the linear equation, solved for dose, results in a BMD of 21.4 micrograms per liter and a BMDL of 17.3 micrograms per liter. And then we convert those drinking water concentrations into our daily intake measure of micrograms per kilogram day. Next slide. That ultimately gives us 4 points of departure for the 4 non-cancer endpoints that we considered for the reference dose: CVD incidence, IHD incidence, diabetes, and birth weight. We apply a composite uncertainty factor of 3 to those points of departure. We don't use a uncertainty factor for animal to human. Extrapolation is not necessary. Subchronic to chronic is not necessary. Low AL to no AL is not necessary. And then given the breadth and depth of the arsenic database, we used an uncertainty factor of 1 for the database uncertainty factor. And so that leaves the inter-individual variability uncertainty factor. We used a value of 3, accounting for the fact that the studies that were used in the meta-analyses and the Kyle study were conducted in sensitive subpopulations. And so that warranted dropping that uncertainty factor from the default value of 10 to 3. And then that leaves us with 4 candidate values from which we select the overall RFD of 0.031 micrograms per kilogram day based on CVD incidence. Next slide. Thank you. And that's all we have. And I think now we're going to open the panel for clarifying questions, I think.
Yes, indeed. Thank you very much, both you, Dr. Lee and Dr. Davis. So I'm sure we're going to have a lot of interest. We're following this raise your hand if you have a question. And if you slide your name to the end of the plastic thing, it stands up better. So I think I've seen Dr. Gribble and Dr. Pennell showing interest. So go ahead, Dr. Gribble.
Just as a clarifying question for the language used to describe the analysis. So the MR meta-regression analysis, I had been thinking that referred to the dose response meta-analysis, but is that actually the second stage model where you're fitting the polynomial through the fitted values, or no?
No, so I think we might be in what we refer to as the meta-regression, and others have recommended be called a dose response meta-analysis, is the fitting of the logistic model, the hierarchical logistic model, to the individual study data in order to derive the logistic slopes for the individual studies and then the pooled slope. And then that pooled slope, well, the study specific logistic slopes and then the pooled slope are then used in the life table analysis to derive those lifetime extra risks. So it's the dose response meta-analysis and then the life table analysis together ultimately give us the lifetime extra risks that we present in the assessment.
Okay, Dr. Pennell.
I think I may have noticed a typo in your slide because it's like definition of the BMDL is inconsistent with what you describe here. I just want to make sure it's a typo.
Okay.
And that the document's fine. You mentioned that to calculate the BMDL, you used the lower bound on the slope, but it should be the upper bound, right?
The upper bound.
Yeah.
So,
So
yes,
the
yes,
slide said lower. It said okay.
Okay.
Got it.
Yeah. The 95th percent lower bound on the.
No, it should be the upper bound on the slope because that room for higher
right,
risk, and so they'll give you a lower benchmark dose. Yeah.
Yep. Sorry about that.
It's okay.
That was on
it can
slide,
be confusing at times.
Slide 25, I think. Yeah. Yeah, I wondered about that too. Thank you.
Sorry
for
about
clarifying that. Yeah. Dr. Barton. Sorry, I thought I saw you putting yours up. Okay. Dr. Post, yours is definitely up.
My first question's really basic, so maybe it's something that I'm just not understanding, but if we know arsenic's like almost all of it's excreted in the urine, why do you need a PBPK model?
We needed a justification to make that assumption, and that the PBK model showed that. The El Masri model showed that there was a 1-to-1 association.
But if like you had data that just data, not a model, experimental data that like almost none's excreted in the feces, that it at steady state, or the hair, I guess, or toenails too, maybe. It like from data, why then can't you just assume what at steady state the intake equals what's in the urine or close without a model?
That would have been an equivalent of yes.
It doesn't affect the iris assessment. It's more for my own understanding.
Right. It's two approaches to show that. Like you could make that assumption based on the empirical data. We based our assumption on using the PBK model to show that quantitatively.
Okay, thanks. My second question, it might be in the document, but I just wanted to ask. I didn't. For the Kylie study, it's based on drinking water exposure, right?
Yes.
So when you did the exposure, to convert it to micrograms per kilogram per day, did you use the higher drinking water intake of pregnant women compared to default adults?
Yes, I believe so. I mean, we can check on that, but yeah, we used water consumption rates from the exposure factor handbook.
For pregnant women?
I believe so. Yes, ma'am.
Okay, thanks.
So I had a couple questions. One pertains to the handling of studies that use toenail for exposure assessment, toenail assessment of arsenic. Where that was the only metric for exposure, those were excluded, I understand, because the PBPK model doesn't account for exposure assessment from toenails, correct?
Correct.
And if a study had measures of the concentration of arsenic in the drinking water and toenails, those were included, but the drinking water data was used, not the toenails, right?
Right.
And then as you stated, for pregnancy studies and adverse birth outcomes, since the PBPK model does not account for transplacental transfer of arsenic, those were excluded, and that's why you relied on that, right?
Biomarker studies for pregnancy outcomes were excluded.
Yeah.
Yep.
Okay. And I know Dr. Karagas has done a lot of work with toenail and comparing that to other sources. So I'd be interested to maybe talk to you about your view on that, if there's some way that data could be used appropriately or not. Okay, and then the other question I had was you mentioned in your slides just now when you were talking about the RFD derivation and birth weight, that you re-expressed the regression coefficient. So it was modeled as a logarithmic function, and you re-expressed it. Did that account for the shape of that and re-expressing that, or was it linear, both as a log function and as a linear function?
That I don't know. It's an approach we've used in other assessments So for other assessments where you might have a number of studies where the regression coefficient's been expressed in a variety of ways in order to, again, use more studies, we have preferentially re-expressed everything to be on the normal scale.
Mm-hmm.
And so that's the approach that we used here as well.
Okay. Yeah, I'll have to think about that, because I'm thinking about a logarithmic function that might be linear in the log domain, but then you transform it to a Cartesian domain and it's no longer linear. So I have to think about that. Thank you. I want to, before I go to the next two who have their tents up, I just want to ask if any of our online participants have questions that they'd like to raise. Yes, go ahead, Dr. Navas Asian.
But thank you. Just a question about the baseline risk. I understood that you are using this 0.7 as the baseline risk, and I was wondering if do you do sensitivity analysis for that? How is that influential or not in your excess risk estimates, and how does that account for changes over time in underlying risk?
So the value that we used is meant to. So for CVD incidents, IHD incidents, and diabetes, we didn't have that age stratified mortality and morbidity data. Like if we had that data, that's what we would use in our life table analysis, because that does take into account that change over time with increasing age. But the singular value that we use is meant to represent the overall lifetime risk. We haven't currently conducted a sensitivity analysis to see if higher or lower values for that lifetime probability, how that impacts the final results. It is a sensitivity analysis that we could include, but we haven't done it yet.
Thank you.
Dr. Pessa.
Thank you. I acknowledge that, the neurodevelopment data was not modeled, but I wonder, it does raise a question. Arsenic accumulates in the brain and probably other tissues. Is that at all considered in your modeling, that the accumulation of arsenic in particular tissues?
Dr. El Masri is on the Zoom call, so I think he might be better, more appropriate to answer that question about the specific structure of the PBK model.
Yes. Can you hear me?
Yes, we can hear you. Go ahead.
Okay, cool. So we in the model we do have the disposition of course, it's in many situations it is predicted, but in the situation for the urine, the model was calibrated to data. So in the absence of human data of inorganic arsenic in the brain, it would be more or less a prediction that is had to be verified. So the reason we use the urine data is because of its availability as data to calibrate the model. I'm not so sure if I answered the question, but that's the mechanics and the thought that was behind it.
So I guess that's a no. I just.
I mean, a no for what?
For accounting, there's some very nicely done animal studies that show a 6 to 10-fold accumulation that's regio specific in the brain, hippocampus versus cortex. And that seems like a large factor that may not be included in your PK model.
I mean, so we could use the PBK model to estimate levels of the chemical in the brain, but as far as the linkage between exposure, which is what we're after, like what's in the water, let's say, or food, versus how the model predicts the urine levels, or going back and forth between urine levels and exposure. Since we had urine data, it was more appropriate to use that. But we can, like I said, it would have been a prediction to look at the levels in the brain in humans.
Dr. Pessa, is that sufficient? Any follow-up?
No, thank you. That's sufficient.
Okay, thank you. And thank you, Dr. El-Masri, for helping out here. Dr. Borsak, did you have anything before we? Okay. Next, we have Dr. Wyckoff.
Thank you. So my clarifying question is more about the data that go into the model, and just reading through some of the comments and rereading the assessment here coming in today. I just wanted to clarify the data that are being modeled. Were they always the most adjusted information from that study for the covariates or confounders, for example? So were you always using adjusted data?
We were always using adjusted odds ratios and relative risks. It may not have been the model that adjusted for the most covariates.
Okay. And then with respect to the covariates, the criteria to be eligible for dose response included consideration of outcome-specific covariates, as I understand it. Is that correct? So if you were looking at a specific outcome, a certain cancer type, you would have considered covariates specific to that outcome. Is that?
We can, no. Okay. We weren't looking at a set of, critical covariates for bladder cancer versus lung cancer.
Okay.
We did use control for smoking as a critical cutoff, because smoking is associated with all the diseases that we ended up modeling. So studies that didn't control for individual smoking, or they didn't control for smoking on a municipal level in a couple of cases, those were excluded from dose response.
Okay. Okay. And then somewhat related, you talked about just using the Wasserman study as an example, the neurodevelopmental. The focus of what we talked about today here was more about the model fit. But the assessment also talks about the potential impact of co-exposures to lead. And that's discussed in the assessment as one of the reasons not to rely on the study. And the comments even made that the study did not control for lead exposures, and the IQ measures were similar of what you could be expected from lead exposures. And so that kind of just led me to think about, in all of this modeling, did the agency consider any methods to assess the impact of uncontrolled bias or unmeasured bias or residual bias as it related to what's being modeled? So there might have been some, for example, you said that there were not outcome specific covariates considered. So if something that was, let's just use smoking, let's just pretend smoking wasn't evaluated, but smoking was associated with that outcome. Did you use any of the existing methods to assess the impact of not controlling for those important covariates on what you were actually going to model? So the data going in has some uncertainty because of those elements. Was that considered at all in the modeling?
We did not use modeling that tried to account for confounders that were not included.
Okay.
Martha?
Well, we cannot hear. Can we?
Yeah, we're working on that. Hang on. Thanks, Anna. And please introduce yourself, Martha.
Hi, I'm Martha Powers. I'm an epidemiologist with the Arsenic team. I think that to address some of your concerns, it comes before the dose response part. And so that's addressing confounding is done during the risk of bias process. And so we do that at the study level. So the studies that are the medium high confidence that get to Allen we've already addressed those concerns. And it's deemed that the risk of bias has been low for whatever the study has been able to address for confounding.
Okay, and then with respect to, so the risk of bias was evaluated at on the study level at the study evaluation phase, and then additional criteria were applied for the dose response. Both of those consider confounding and covariates. Were those the same? So let's say when it underwent study evaluation for risk of bias and you looked at, I think it's domains for like 2 and 3, confounding and co-exposures. Were those the same things that you looked at for eligibility for dose response when you looked at covariates? Or did you add or change the requirements?
Not necessarily with respect to covariates, or confounding, but there were additional study characteristics that we considered for dose response. So a study could have been found to be of medium or high quality, low risk of bias, and got to consideration for dose response, but then ultimately not suitable for the Bayesian dose response meta-analysis because they didn't express, they didn't have categorical measures of dose, or they didn't report some, they didn't report person years for a cohort study, something that we needed to do the pre-analysis conversions in order to get to the dose response. So there was an additional set of considerations that we took into account to identify the studies, the high and medium, low risk of bias studies, to move them into quantitation.
Super, thank you.
Dr. States, can I jump in here with a follow-up? Thank you. So if a study meets the criteria and the screening and comes up and is judged to be of low bias and high quality, that published study, peer-reviewed study, probably has done an analysis with multiple levels of adjustment, maybe unadjusted and adjusted, and maybe 2 models of adjustment. And so then as I understand it, you're selecting the adjusted data that they used, and probably the most robust model that they ultimately determined was the best for their study. And then you're taking that data and you're not doing any further adjustment, right?
No, so I didn't include a slide on this, but the calculation of what we called effective counts is a approach to generate the incidence data that we need for the logistic model that retains the study conducted control for confounding. We didn't do any other adjustment to account for, confounders that weren't included in that model.
Yeah, thank you. So Dr. Oh.
Come up.
And when you come up, please introduce yourself.
So my name is Jeff Gift, and I was assisting with the dose response aspects of the arsenic assessments. I just wanted to say that we did look at the studies and generally chose the study that addressed the confounders that the authors thought were appropriate. In the most important, probably, study for the CVD instance, which is driving the RFD, the Moon 2013 study, they did look at several different models that adjusted for different confounders and or cofactors, and we chose not the most complex model. We didn't choose, for instance, in this case, the model that adjusted for diabetes and hypertension. And that's because, and the reasons are described in the assessment, but we did look to address your comment. We did look at the difference between the adjusted and the unadjusted results in that case, and there wasn't a big difference, first off. And that secondly, we felt that it wasn't appropriate to include those diabetes and hypertension in this case in the adjusted model because, if as adjustments in the model, because of the relationship between arsenic and those factors, because it's along the pathological progression potentially. So,
yeah, thank you for clarifying that, Dr. Gift. Okay, so we have Dr. States and then Dr. Borsuk and then Dr. Pesa.
I'm going to change the focus for just a moment, which is comments that Dr. Lee presented. I understand the reasons for not considering mode of action in this analysis, and they're using the epidata, which span the region, and that's fine. But some of the reasons given for dismissing the MOA, like the high in vitro concentrations used, both in vitro and in some of the animal studies, those have been superseded more recently by concentrations that are reasonable. And indeed, they've actually shown different targets. So I was wondering why you had no consideration of those more recent studies. And some of them are in cancer types that you've dismissed as well, but the mechanisms are likely to be similar.
Right. So the mode of action analyses that we did, that's in the updated problem formulation protocol document, the literature that we looked at there, I think the cutoff date was around 2015, 2016. And so I don't think we haven't seen the newer studies. So.
Yeah, that cut, I'm considering the publications come oftentimes a year or two after the work was done. There's more recent stuff that's within this past decade that you might consider at least examining and including in your arguments.
Okay. Right. Thanks for the comment.
Okay, Dr. Borsuk.
Thank you. I realize that the this prior that you place, or on the gamma prior that you place on the overall mean effect is limited to strictly positive values, and I think that makes some sense given your prior understanding. Yet it does, as you know, force those, if not the individual coefficients, but the pooled coefficients to have this mean that's non-negative. If the data were strong enough to support non-negative mean, then I suppose they would speak for themselves. Did you look at some sensitivity analysis, not to different parameters of the gamma distribution, but to perhaps distributions that might allow for negative overall means?
We did not, but there were some comments in the preliminary set of comments that do make that recommendation. So, I mean, that is, a sensitivity analysis that we can include in the final draft.
Yeah, great. Okay. Yeah, I saw that in the comments, and one of those was my own. I just wondered if you had already done it, then maybe it was moot. Thanks.
Dr. Pessa.
Just to continue on the discussion of Wasserman et al. 2018, that was concluded to be a high quality study with low bias, and yet they excluded, it was a study of course, neurodevelopmental delays, developmental neurotoxicity, basically, and they excluded children with neurodevelopmental disabilities. Is that a bias?
I didn't do the risk of bias for that study. Do you want to?
Yeah, we can look at that and get back to you on that study.
Okay. Thank you.
Okay, thank you. Well, might you be able to do that this week? I mean, while we're here?
Yes.
Thank you. That will be very helpful. I appreciate it very much. Dr. Pesso, your hand's still up. Are you concluded? Yeah, thank you. Dr. Karagas.
I was just going to make the point to clarify your point, Dr. Thorne, about transplacental arsenic exposure, that my understanding is the reason why urinary studies during pregnancy were not included is because the metabolism of arsenic changes during pregnancy. And we can discuss that later, but it wasn't because arsenic passes through the placenta. So I just wanted to make sure you understood that.
Thank you. It's helpful. Thank you.
Okay. Is that correct?
Yeah, I mean, it's just, yes.
Right. Okay, Dr. Wood.
This is along the same vein we've been talking. You, Mr. Davis, you said you excluded biomarker studies of birth outcomes. Was that in the screening process or in the modeling process?
That was in the screening process for modeling.
Okay.
So there were a number of medium and high quality studies that got through study quality evaluation and risk of bias that when it got to, the step where we consider studies for modeling, we realized the majority of these are biomarker studies that we didn't have a method to use. And so them being biomarker studies was not impacting the HI or study quality determination for those studies. It was strictly on the dose response side.
And then along that, on the dose response side, if you do have some high quality studies, but can't model them the way you want to, I'm just worried you're losing an awful lot of information on birth outcome and the neurodevelopmental endpoints that are not addressed in the document because you're discounting them or not using them because they don't fit their I think we can get good information from biomarkers.
If we felt that we had a reliable way to convert maternal urine measures or cord blood measures, if we had a PBK model that could do that, we would certainly use those studies. It's on the exposure side that we're limited currently because.
Do you really need that for urine though? That's a pretty good correlation, isn't it?
The PBK model that we're using to support that assumption of a one-to-one relationship was not parameterized in pregnant women. And so
Sorry, I'm still taking notes. Dr. Wyckoff.
Yeah, just clarifying, kind of going backwards a little bit, and this might be for Dr. Lee or the epidemiologist. I just want to clarify that in the risk bias, or the first time that you looked at confounders, covariates, modifiers, et cetera, were there any outcome-specific criteria determined other than this, than what is in the protocol for, I think it's like just a couple of outcomes, skin cancer and something else? So for example, for cardiovascular disease, did you identify, you know, the covariates or known risk modifiers that ideally a study would look at ahead of time?
Right. So for risk of bias at that step, we did not have the covariates or confounders a priori.
Okay, thank you.
Dr. Post.
My question is following up on what I asked earlier and what Dr. Wood was just asking. Is there like a reason to believe that almost like without a model that pregnant women don't excrete at steady state almost all of the arsenic in the urine? And I guess it's the same question I had earlier, like why can't you just make the assumption that the urinary excretion represents the intake, the dose, the intake for pregnant women too, even if the model wasn't that parameterized for that?
if there was empirical evidence to support a one-to-one relationship for pregnant women, then we could use that to support using urinary biomarker studies for pregnancy outcomes.
That's what I guess my question is there empiric evidence for pregnant women that you just said, aside from the model not being parameterized?
Not that I'm aware of right now, but I mean, if there is and somebody can point us to that, I mean, we could definitely use that for an assumption as a basis for supporting an assumption. So it's.
Okay, thank you very much.
Yeah, go ahead, Dr. Gribble.
I can look this week for a specific citation for you, but as a kind of high level heuristic, the percentages of different urinary arsenic species metabolites in pregnant women changes across trimesters of pregnancy. But the total, like the sum of the species, is relatively stable across time, across pregnancy, depending on if the women have had exposure changes. And so would something sort of qualitative like that be sufficient rationale for including the biomarker studies, at least in a sensitivity analysis, meta-analysis?
Tentatively, yes. I don't want to make any conclusive determinations here, but again, if we had evidence that, you know, again, there was a one-to-one relationship, and we can show that from empirical data versus the PBK model that we're using for, you know, adults, non-pregnant women, I think that would be, we could at least consider opening up the pregnancy outcome analysis to urinary biomarker studies.
Thank you. Okay, go ahead, Dr. Wyckoff.
So I have actually a clarifying question. Back to Dr. Thayer indicated there were lots of pieces. I just, are the low and uninformative study evaluations in Hawk?
Yes, they're in Hawk. So to access them, you can go to the literature tree, and if you click the node, it should send you to a table that lists the studies. And if you click on the study and scroll all the way down, you would see the study evaluations for the low and uninformative. So yes, they should be in Hawk.
Okay, great. I only got part of that way, so I might request some assistance with that at some point. But thank you very much.
I'm not seeing any tents up, and I'm not seeing any hands up online. giving plenty of opportunity. Okay. I think you've satisfied everybody with their questions at this point. I'm sure we'll have more that'll come up and we'll be reaching out to you. But I want to really thank you very much for your presentation and your thoughtful answers to our questions. We're, I think, ahead of schedule, which is amazing. So we have had the clarifying questions, and we are scheduled for a short break before public commenters are on. Some of them may be waiting for the time. Let me confer with DFO here on this. Okay, so we don't have to wait till 11 to start the public commenting, and if somebody on the list isn't ready to go, we can just swap the list. So we were scheduled to have a 10-minute break, so why don't we make it 13, which takes us to 10:50 local time. So we'll be on break till 10:50 local time. Thank you. Okay, we can reconvene, please.
Can he ask questions?
Okay, if everyone could take their seats, please. We're ready to go. And I'm asking if Dr. Joyce Suji is ready to go.
Yes, I'm here. Thank you.
Okay, excellent. Okay, so our first speaker from the public, let me just say at the outset that we really appreciate the public commenters taking the time to present to us and bring their views forward, both in person or online, and with their written comments. We've received a large amount of written comment before our last meeting, and indeed before this meeting leading up to yesterday. So we really appreciate the input that you're all and the effort you're putting forward to bring that to us. So our first public speaker, and let me just say too, after each public speaker, there'll be an opportunity if anyone on the panel has any kind of clarifying question that they want to bring, they're certainly welcome to do that, and I'll offer that time. Okay, so first is Dr. Joyce Suji, who's affiliated with Exponent, and you have 5 minutes, so go ahead.
Yes. Oh, good. The slides are up. Thank you. The SAB has an important opportunity to help the EPA improve the scientific basis of their assessment. Within the systematic review, a more rigorous risk of bias assessment will help ensure the use of the most reliable data and a more accurate assessment of the dose response of arsenic. Next slide, please. I just wanted to state that I have not received funding to prepare or present these comments. My employer, Exponent, received partial funding from the Arsenic Science Task Force to provide comments to the EPA on the draft assessment, and I've consulted to industry, EPA, and state agencies on arsenic. Next slide, please. It was difficult to determine which data from studies were used in the assessment, but I'll provide a few examples of areas for improvement in risk of bias. First of all, confounding for lung cancer and cardiovascular disease by smoking, and also bladder cancer by Diploito et al. 2015. This study also presented bladder cancer risks, but they weren't used by the EPA assessment. At any rate, smoking was not corrected for on an individual basis, and therefore is very imprecise. Smoking is a major risk factor for bladder cancer, lung cancer, and cardiovascular disease, so this is a major problem. And because smoking adjustment is difficult even for individual level data, EPA really should assess the individual effect of arsenic from studies of never smokers, and there are quite a few of those data in the various studies. Please see Suji et al. 2019. Next slide, on confounding. The data selected that EPA selected from Moon et al. 2013 appears to be uncorrected for hypertension, diabetes, and albuminuria. The adjusted results are available in this study and should have been at least looked at and used. The factors like diabetes, albuminuria, low lean body mass are also independent risk factors for cardiovascular disease. So they really should be considered. And the exposure metric, which was creatinine adjusted speciated urinary arsenic, is affected by things that result in low urinary creatinine. So low urinary creatinine would increase the adjusted arsenic urinary level. Low urinary creatinine is associated with diabetes and albuminuria. And as a measure of muscle mass, it's also an independent predictor of cardiovascular disease risk and mortality. There are also very small studies that show that small increases in these parameters can result in actual increased risks of cardiovascular disease and also may increase cancer risk. In the next slide, a follow-up study by Ku et al. 2022 shows what happens when you don't adjust for creatinine or adjust for specific gravity. The hazard ratio goes down considerably and actually is less than 1 in the non-adjusted model. And this is even adjusted for albuminuria and diabetes. Next slide shows data from Ku et al. Next slide, please. Oh, yes, I'm sorry, cancer mortality. And the same effect is shown. So this should be considered in the assessment. In the next slide, control population differences. There are 2 bladder cancer case studies, hospital-based case control studies, in which the control is not exactly a good control for the cases, because the control were people without cancer, including those receiving health exams at the hospital. So it included healthy individuals. And the problem with that is the exposure metric, again, was creatinine-adjusted urinary arsenic after diagnosis in this case. And the reduced health status and low muscle mass of the cancer cases could have reduced urinary creatinine levels, which would have increased the apparent arsenic urinary creatinine-adjusted urinary arsenic level. The same research group, both of these studies were conducted by the same research group and had overlapping patient populations. And therefore, it really is double counting the same study. And any leave one out analysis should eliminate both studies. It's not clear that these studies are really measuring inorganic arsenic exposure, and risk. Next slide, please.
You're at time, Dr. Suji.
Okay, I'd appreciate if the SAB would read the rest of my comments in the slides. And thank you for allowing me to present today.
Okay, thank you very much. And we do have those, and I was able to look at them already, so I know that they're available to the panel. Thank you very much for presenting. Next, any clarifying questions before we move to the next speaker? Yes, go ahead, Dr. Gribble.
Thank you very much for these well-considered comments. I have a clarification question. You referred to independent risk factors such as diabetes, and they're not independent if they're endogenous to the system. So if arsenic affects diabetes risk, as the National Research Council concluded as likely and was the conclusion of this risk hazard identification, then conditioning on a mediator would attenuate the association and introduce a bias from appropriately estimating the arsenic risk. So I was wondering if you were distinguishing mediation versus like a confounder situation.
Yeah, I think it's very difficult, but it is there. The publications I list in my slides show that there's been a well-established correlation and association between diabetes, what diabetes results in terms of creatinine levels, and albuminuria and low lean body mass. So I guess the association of arsenic and diabetes would also have to be carefully looked at as well. I think Dr. Buffetto will be talking a little more about that. It's not a strong association with diabetes, not as strong as the effect of diabetes on creatinine levels or albuminuria on creatinine levels. So I think all these associations need to be considered.
Okay, thank you. Our next public speaker is Dr. Kevin Bromberg, who is affiliated with Bromberg Regulatory Strategy. Please, 5 minutes. I'm happy to cue you at 3.5. Please turn your mic on so we can hear you.
Excellent. Let me put my timer on. Sorry. Hi, my name is Kevin Bromberg, a consultant with expertise in environmental and scientific matters, having recently retired from the federal government after federal government service in the U.S. Small Business Administration. I'm the only presenter you're going to hear from who offers a perspective from inside and outside the IRIS program with over 40 years of government experience. So at the first meeting, you heard from Chris Thayer, Tom Brennan, and Dr. Thorne that public comments are very important. So the pivotal question for this panel is, will this be a thorough and robust review, or is it going to mirror the flawed 2010 Arsenic Work Group review? In that review, all the public commenters, all of them, like you're hearing today, to challenge the EPA draft. The reviewers who criticized the EPA in the previous 2007 review were excluded from the 2010 panel. And this led to EPA retracting its discredited report the next year. So despite the statement you've heard about the importance of public comments, how can we make public comments an important part of the dialogue, as opposed to just saying, you know, we listened to you for 5 minutes? I was concerned that at the first meeting, neither the DFO nor the committee chair acknowledged the public comments sent to the SAB during the entire discussion of the charge questions. And I realized we only had 2 weeks for you to prepare preliminary comments. So kudos to Drs. Gribble and Wyckoff for acknowledging that not only they've read some public comments, that they actually made sense to them. So how can the public and the EPA have confidence that the SAB is doing its job here? So the panel can rectify this now. It's still only meeting 2. And I have 3 asks in my written write-up. By the way, this is a shortened version of the earlier version, which is 24 pages. I don't recommend very many of you folks spend the time with that. First, it is essential that the panel members directly address the substantial points made in the detailed public comments, ensuring EPA receives the most robust science advice. Secondly, to effectively evaluate public comments, the panel members should request additional explanations from selected commenters beyond the 5-minute statements. The panel could specifically request a more in-depth discussion between EPA authors and public commenters, especially when the latter possess unique expertise. Panel members could use this as an opportunity to directly pose questions for EPA or public commenters. A mere 5-minute slot does not do the job. Lastly, in line with current SAB policy, the chair should consider adding a brief public comment period at the end of each day. This would allow for reflection on the day's discussions and charge questions, a practice often overlooked, but has been used in the past. I observed multiple opportunities where experts with decades of experience were exasperated by major errors made in discussions among EPA authors and panel members and being powerless to make corrections in real time. You know, we have a collection of world-class scientists here in the room and online. Don't they have something more to offer that EPA can dialogue with?
You're at 3:30.
Okay, let's go to the slides. If the slides can be put up. Do we have the slides? Okay. So the first slide when it comes up is, what conclusions can we be drawn from these data in the next 3 slides? The first 2 are figures from Suji et al. 2019 and 2021. And the third is an EPA slide. Can we make that slide bigger for the audience? Well, okay, the first 2 slides the first two slides, one is bladder cancer and one is lung cancer. And can we move to the next slide? Okay, you saw the earlier two slides, which show that at low dose, there's no effect for two kinds of cancer. So you might wonder what the difference is between EPA's approach and conclusions and these results. We're also now looking at the EPA slide on low dose data. What studies contributed to this pooled data that's here? Is this the actual data points? How are they adjusted? How did they combine low dose and high dose data? Next slide, please. And you're going to have to read this at your leisure. Interpreting charge question 5, the EPA cancer guidelines say nonlinear approaches should be selected when there's sufficient data. Well, in the SUGI articles, it's more than sufficient data. This is an established MOA. If the SUGI studies were under review by the SAB today, instead of the EPA, would we reach the same conclusions that they are appropriately described and scientifically justified? Can you reconcile both of these determinations?
You're over time now. So I gave you an extra half a minute because of the delay in getting the slides up. So we appreciate your written comments. I did look at the 24-pager. I'll look at the shorter version too.
I think you have better use for your time, Dr. Thornton.
Well, I'm not sure I agree on that. So are there any clarifying questions from the panel? Yes, Dr. Gribble.
And thanks, Dr. Riddle, for your comments.
So there have been a substantial number of public comments provided, which is wonderful to have this input in written format. And several of them make similar points about, for example, two ecological studies for skin endpoints having a nonlinear dose response in the low exposure range. But the EPA assessment was very clear why these kinds of things might be excluded. Is it necessary to regurgitate public comments that are sort of already addressed in the draft document?
So it's your job to comment on their review and what they said. But there's two things. One is you want to agree or disagree with EPA's justification. A number of the people in this room or outside this room clearly disagree with EPA's justification, and that when you're doing the pre-analysis that you heard about and the Bayesian manipulations, and then you'll hear about the beta and the slope curve, you'll hear more about the technical details from other scientists more qualified than me. You will hear the fact that those additional modeling assumptions more or less force them into a linear situation. And therefore, an understanding of the MOA would have helped EPA instead of assuming that it was linear, which is more or less what happened. They would be open to to looking at other polynomial fits and other types of analysis. The second thing that I think is very relevant, which is the point of the earlier slide, is that EPA is presenting, one point of view and one set of analyses. It is still our job to look at the literature, even though they cut off the studies at 2015, 2016. But some of the most, critical studies did occur, and they were sent to you folks also months ago. You will see very strong evidence which is consistent with an MOA, which EPA does not have a plausible biological basis for its approach. It would cause one to wonder why those studies, which were peer-reviewed studies, multiple of them are coming to a conclusion that's opposite of EPA's. You'd want to know why that is. And it's quite possible, plausible. If I were in your shoes, I could say that both of these approaches may have scientific justification, but you'd favor potentially one over the other, depending on your review.
Okay. Are there other questions from the panel? Clarifying questions?
Good question.
Seeing none, I want to thank you, Dr. Bromberg, and call on Mr. Alan Prouty from Simplot. Are you with us? Dr. Prouty, are you on? I see the name is showing up on our roster of participants. Well, why don't we move on and come back to Dr. Prouty? And next up, then we would ask for Dr. Barbara Beck. Are you on?
Yes, I am.
Okay, Gradient on behalf of the Arsenic Scientific Task Force. Please go ahead. You have 5 minutes.
Thank you. To start, I want to make 2 disclaimers. First, these comments were financially supported by the Arsenic Science Task Force. However, the opinions expressed here are mine and those of my Gradient co-authors. Second, I'm a member of the EPA Science Advisory Board. The opinions I express here today are unrelated to that work. Gradient's comments address 2 key issues. 1, comparing the draft IRIS assessment to other assessments conducted by food safety organizations over the past 15 years. And 2, the implications of the proposed slope factor on risk assessment, communication, and management. The proposed slope factor of 53 is much greater than those derived by 3 food safety organizations, EU's EFSA, the WHO's JECFA, and the FDA. We compared the US EPA assessment to these other documents on 7 different metrics, such as study selection and exposure characterization. I will present example conclusions from this comparison, but the full tabular summaries across the different agencies and the 7 metrics were submitted, I believe, about a month ago to EPA and is available on the SAB website. EFSA and subsequently JECFA use benchmark dose modeling for key studies for bladder and lung cancer. JECFA's approach is more robust than that of EFSA, relying on more recent studies and using different model fits to the data, among other components. Subsequently, FDA evaluated cancer's risk from consumption of apple juice, rice, and rice products. These assessments built on the analyses conducted by JECFA, but added refinements to increase the robustness of the risk estimates, such as applying a lifetime risk adjustment factor to account for differences between the cohort follow-up period and the lifetime. The arsenic potency estimates from these 3 organizations have decreased over time, in contrast to US EPA, where multiple assessments over time have generally resulted in increased cancer potency. EPA's draft assessment approach differs from other agencies in a number of ways. For example, instead of conducting benchmark dose modeling on 1 key study for each cancer type, EPA used Bayesian meta-regression to derive a pooled dose response curve for each cancer type, allowing the use of multiple epidemiological studies with different study designs. With respect to exposure characterization, many assumptions are made when extrapolating from the exposure information used in an individual study to a common dose metric, leading to uncertainty. In particular, with respect to EPA's approach, there are significant limitations to quantifying dose based on urinary arsenic levels, especially when a creatinine adjustment is used, because creatinine is associated not only with urine volume, but also with folate levels, which can influence arsenic metabolism, as discussed by Dr. Suji. Variability in study results is reflected in the range of excess risk lifetime risk estimates across studies. Figure 4.6 shows the mean extra lifetime risk at 10 micrograms per liter in drinking water range from below 0, indicative of a protective effect, to risks greater than 1 × 10⁻³ . Similar variability is observed for lung cancer. We believe that US EPA should consider more fully the benefits and drawbacks of relying on more studies in comparison to the choice of a single study by the 3 agencies listed. Another difference between EPA's assessment and other agencies is that EPA considered lifetime extra risk, the extra risk above baseline at 0 arsenic dose. In doing so, a single value was chosen for background arsenic, but background arsenic levels in water and diet can be highly variable, leading to uncertainty in this value. With respect to risk management and communication issues and the proposed cancer slope factor, I note the following. Communicating arsenic risks has traditionally been very difficult, but the proposed high potency factor for the EPA cancer slope factor will increase public confusion because of the disconnect between calculated arsenic risks and environmental exposures deemed public health protective. As an example, at the proposed cancer slope factor, the cancer risk from drinking water at the maximum contaminant level would be 1.6 times 10 to the minus 2, or 1.6%.
You're at time, Dr. Beck.
Okay, thank you.
Thank you very much for your input and your written as well as oral. Are there any clarifying questions for Dr. Barbara Beck? Okay, thank you very much. Nice to see you. Okay, let's go back and see if Dr. Alan Proudhey is ready to go. Are you with us? Okay, apparently not. So how about Dr. Kan Shao? Are you on? Oh, you're here in person. Sorry about that. Thank you for your presentation.
I have slides.
Yeah, we'll get your slides up here. There we go. Okay, please go ahead. 5 minutes.
Thank you very much for the opportunity to speak today. My name is Kan Shao, Associate Professor of Environmental and Occupational Health at Indiana University and a board certified toxicologist. I have 15 years of research experience on dose response modeling, especially on the development of benchmark dose methodology. I have a few publications on developing advanced Bayesian modeling approaches for dose response assessment for inorganic arsenic using epidemiological studies. Next slide, please. My comment in my presentation today will primarily focus on the dose response assessment approach implemented in the IRIS inorganic arsenic toxicological review. These comments are related to the charge questions 4, 5, 6, 7, and 8. The entire dose response modeling framework used in this study mainly consists of 2 parts, as shown on the right-hand side. The first part is the Bayesian hierarchical model-based meta regression to analyze the multiple epidemiological studies. This approach was applied to various endpoints, and the outcome from the meta regression was a distributional estimate of the mean value of the pooled slope parameter in the logistic model. The second part involves utilizing the estimated slope parameter and the life table information of the US population to estimate the extra risk of various endpoints, including both cancer and non-cancer. The extra risk estimates were further used for low dose extrapolation, which were dichotomized for cancer and non-cancer effects. So both parts have issue, but I will further explain, but the second part, especially the low dose extrapolation, is seriously problematic. Next slide, please. The primary concern in the first part of the approach is related to the model uncertainty, including a few aspects. First, the logistic model used in the meta regression was described as flexible and nonlinear. The logistic model is a 2-parameter model, which is one of the simplest dose response model for dichotomous data. So the logistic model can illustrate a sigmoidal shape, but it's not really flexible. Because of the very limited number of parameters, the shape of the curve can be substantially affected by response value in the high dose range. Second, it's not clear why the slope parameter in the logistic model was used in the life table calculation for the lifetime extra risk estimation. Why not a slope parameter in a probit model or other models? So it's important to note that the slope parameter is a model specific. The third, the 2 models were compared with the logistic model were the fractional polynomial model and the double Hill model, which are 2 very uncommonly used and also overly complicated. Why not use the more commonly used multi-stage model with unrestricted parameters so that it can also demonstrate a J-shape dose response relationship in the low dose range? Next slide, please. Starting from the step of extra risk estimation for various endpoints, the dose response assessment approach became problematic. On this slide, I collected 5 extra risk versus exposure plots for 5 different endpoints from EPA's documents. To me, all those 5 endpoints show a very clear linear dose response relationship. Is this because all those endpoints demonstrate a linear dose response relationship in the low dose range? I don't think so. I believe this is primarily because the way EPA analyzed that, because we only use the slope parameter, the beta mean, and also using the life table information. Also, it's important to note that the 9 dots for the MLE estimate and another 9 dots on each plot, another 9 dots for the upper bound estimate were all estimated data. So fitting model to the estimated data is problematic because we can generate as many dots as possible if we want to. So which will change the model fit. Next slide, please. So there are 3 points I make on this plot, on this slide. I already mentioned fitting estimated data for low dose extrapolation is seriously flawed. The second point is on this slide, it's mentioned that it's not a benchmark dose methodology to estimate the BMDL. The main reason is that the input data, the modeling algorithm, and the interpretation were not consistent with the typical typical benchmark dose methodology. I think Mr. Alan Davis already agreed with that in his presentation. Eventually, estimating reference dose on the so-called BMDL value assumes that the dose response relationship below the BMDL value, BMDL level, is nonlinear. However, the plot on this right-hand side clearly show that there is a linear relationship there. So if EPA don't think the estimate in the low dose range are reliable and ignore that, then the estimate for lung cancer and bladder cancer are not reliable either. Thank you.
You're over time. Thank you very much. I see a clarifying question from Dr. Pinnell.
Yes, thank you for your presentation, Dr. Shao. So you were a co-author on the paper in Environment International describing this methodology where there was an argument made for why a logistic model had to be used. So can you explain why you were okay with that choice at the time of publication and now you're submitting these comments contradicting that?
I have a follow-up paper after that. Actually, I already explained why I think the logistic model is, well, I would say it's okay to estimate, but still those limitations should be acknowledged. It's a 2-parameter model. It's inflexible, so you cannot claim that is a flexible model. And I clearly explain that in my paper 2021, a follow-up paper.
Okay. Are there other clarifying questions? Yeah, go ahead, Dr. Gribble.
Would your recommendation be that they compare in sensitivity analyses alternative distributions? For example, you said complementary log, and see how that affects the distribution, because a lot of those are still going to be sigmoidal shapes that you were suggesting they use as alternatives.
Oh, C-log, I mentioned C-log. Probably it's not the best choice. Maybe the problem model. This problem model has a very similar performance as the logistic model. So a comparison between logistic model and the problem model should be a good choice, good start.
Okay. Thank you very much, Dr. Shao.
Thank you.
Appreciate your thoughtful comments. Next on our list of speakers is Dr. Nancy Beck, Hunton, Andrews, and Kurth. And I believe you are in the room. Yes, you are.
I have some slides also.
Okay, we'll get those slides pulled up.
Great.
There they are.
Perfect.
You may start. Go ahead.
Great. Thank you for the opportunity to speak today. I'm Nancy Beck. I'm a toxicologist with the law firm Hunton, Andrews, Kurth. I am not a lawyer. Next slide, please. I just want to be very clear about my conflicts and disclaimers. all my remarks are my own. I don't represent any of our clients or Hunt and Andrews Kurth. And before diving in, I really want to thank you all for your time as a public stakeholder. I know how much time this takes, so I appreciate you digging in. Public comment is, peer review is very important to ensuring that EPA science is robust, objective, and seen as the best in the US, and that's what we want. So I'm providing my comments today because I listened to the January 5th presentation, and I was really shocked by how little biology there was and how much it was about the modeling. And in fact, when questions were asked about the modeling, it became even more complex. And as we've seen in these discussions today, it keeps getting more and more complex, at least to me. So raise some red flags. I wanted to look into it with limited time. I just looked in one area. Next slide. So I looked at the dose response and mode of action, taking this up way up a notch from what Dr. Shao just presented. So in her presentation, Dr. Lee, she noted that EPA found the impact and utility of mode of action information was incredibly limited. And this was because there was epidemiology data in the low dose range, and that when they have low dose studies, you don't need to extrapolate. That all makes sense. And therefore, based on one case study, which is a little concerning because bladder cancer is just one of the many endpoints, it showed that mode of action actually induced more uncertainty and was less helpful. And Dr. Lee also stated that the NAS in 2019 agreed with this. So this left me flummoxed, so I wanted to look at what the NAS actually said. Next slide, please. And not surprisingly, the NAS agreed with everything Dr. Lee said, so she got it right. It was very consistent, and basically NAS said that if you're relying on data in the low dose range and you don't have to do any extrapolation, then you don't really need mode of action information. And as EPA pointed out, there was one person that disagreed with this. And NAS further went on to clarify the misperception from some stakeholders about this decision. And they said that this didn't imply that EPA would not consider threshold effects, nor would it assume a linear dose response. And then the committee recommended clearly that EPA make no assumptions about the shape of the dose response curve. And of course, they also talked about the importance of mode of action information. So then the next question really becomes, did EPA really use low dose data and not extrapolate? So next slide, please. Because of the limited time, I just chose to look at one endpoint, and I picked the CVD endpoint and incidence endpoint because this drives the RFD value. EPA used a meta-regression using two studies. One study clearly high dose, one study clearly low dose. And EPA fabulously did this leave one out analysis where they showed there's a 93% difference in the beta number. I can't pretend to really know what a beta number means between when you use the low dose study and the high dose study, which means that there's a significant difference in the effect that you get between low and high dose study. But yet importantly, EPA used both studies, and I have on the slide exactly what they said, and they did this because they got a better model fit when they used the high dose study along with the low dose study. So basically, instead of fitting the model to the data, they used the high dose data because it fit the model better that they wanted to, the model that they wanted to use. So that seems, and they also did not consider the mode of action like the NAS said they should. So let me just summarize on the next slide. Glad I'm talking really fast. So EPA combined the low dose and the high dose studies. They did the leave one out analysis. It showed that there were big differences, and then they continue to use the high dose data in addition to the low dose data, just muddying the waters, which would have been fine if they also did a mode of action analysis and made sure that that wouldn't change anything. So it seems to me that this is that EPA did exactly what NAS said that they shouldn't do, right? They forced the data to fit them. They forced the data to fit the model. So if EPA is going to do that, then I just really think they need to consider mode of action information. This is made a little bit more concerning by the comments made today that EPA really didn't evaluate mode of action data past 2016, 2017. So I'll stop there and take any questions. Thank you.
Thank you very much for your comments. Any clarifying questions from the panel?
All right.
Okay. You were 32 seconds less than 5. So sorry? Yes, I think so.
Okay.
Yeah.
Yeah.
You do.
Okay, so
If you have trouble finding it, just ask Dr. Wong. She'll help you. Okay. Our next speaker is online, and that's Dr. Harvey Kluel from Ramboll. Are you on, sir? Okay, we'll come back then. And let's go to Mr. Lucas Joseph from the National Mining Association, who should be in the room. Yeah, I see you coming up. Thank you. Do you have slides?
I do not.
No. Okay, very good.
Hello, everybody, and thank you for your time today. My name is Lucas Joseph, Assistant General Counsel at the National Mining Association. The NMA represents America's mining industry, which supplies the essential minerals necessary for nearly every sector of our economy, from technology and healthcare to energy, transportation, infrastructure, and national security. The reason for NMA's participation today is to highlight three main concerns related to the assessment's underlying scientific basis, inadequate stakeholder engagement, and future regulatory impacts. As the SAB is aware, the IRIS program has a profound impact on domestic and international regulatory programs. Thus, it is imperative that the risk values finalized in this program are based on the best available science. The NMA is extremely concerned that if EPA is allowed to finalize the draft IRIS assessment for inorganic arsenic as written, scientifically indefensible risk values will be used to establish unachievable federal regulatory standards for site remediation, drinking water standards, and waste disposal. First, EPA's assessment is inappropriately narrow and fails to integrate all lines of scientific evidence as recommended by the National Academy of Sciences. EPA has refused to meaningfully extend its analysis of the science beyond epidemiology to include critical toxicological and biological evidence, failing to consider available mode of action data. Reliance on epidemiology studies, which are largely based on exposures at high doses, along with using unvalidated statistical tools to the exclusion of mode of action data, enables EPA to draw unrealistically conservative conclusions about the hazards posed to U.S. population from inorganic arsenic. Incorporating mode of action information would compel EPA to acknowledge the existence of a safe threshold for exposure to arsenic at levels found in U.S. soils. Furthermore, EPA prematurely cut off its review and analysis of the published literature by selectively excluding many important studies. Second, EPA improperly limited public input and engagement during the development of this draft IRIS assessment. Except for the publication of the draft protocol in 2019, EPA offered no opportunities for stakeholder engagement during the development of this draft assessment, demonstrating a lack of transparency. While EPA took over a decade to develop this assessment, it gave the public only a brief 60-day public comment period to review over 600 pages of highly technical scientific information, with a minimal 15-day comment period on benchmark dose modeling data. EPA unreasonably denied multiple legitimate requests to extend the comment period to allow for a more meaningful and thorough review. And now, EPA has needlessly limited the peer review process through narrow charge questions and a truncated review, severely limiting the SAB's ability to consider stakeholder comments and alternative views and conduct a thorough review. Given EPA's unwillingness to allow meaningful public engagement, the SBA must ensure that its peer review is conducted with transparency, rigor, and integrity. Third, EPA proposes overly conservative risk values that will drive unrealistic and economically harmful federal and state regulatory requirements. The regulatory consequences resulting from the draft cancer and non-cancer values will be staggering for soil cleanup programs and drinking water standards. EPA proposes cancer risk factors and reference doses for cardiovascular disease and diabetes that are so low that background naturally occurring levels of inorganic arsenic in the US would be the main cause of these diseases. These risk values make little to no sense from an actual exposure perspective. It is critical that the EPA's IRIS program work more closely with EPA's program offices in performing a reality check on the risk assessment it produces. For the mining industry, setting arsenic cleanup levels at waste sites is complex because of the presence of naturally occurring background levels of arsenic in rural areas and even higher background levels in arsenic in urban areas. We are extremely concerned that EPA's proposed risk values will set impossible soil remediation standards, particularly in many Western states. We are also concerned that these standards would reopen previously remediated mine lands and adjacent communities for further remediation. Upending health protective measures currently in place at Superfund sites across the country would come at a significant cost with no meaningful risk reduction. NMA calls on SAB to consider these concerns and examine the many comments by experts and stakeholders who disagree with this overly conservative conclusions reached by EPA in this assessment. Thank you.
Okay, thank you for your input and your comments. I appreciate it very much. Any clarifying questions? Yes, Dr. Gribble.
So this is a clarifying question about the scope of work for the Scientific Advisory Board. A number of the submitted comments, including the verbal comment you just provided and the written comments corresponding, refer to downstream things that are beyond our scope of work. For example, how this information will be used once a dose response is estimated and a reference dose is calculated. So like we're in general not economists and we're not necessarily policy experts. We're tasked with trying to evaluate the health evidence and provide guidance on what an ideal value would be for protecting human health. And I'm wondering if we need to take into consideration for the hazard identification document these additional concerns, which seems like they'd be more appropriate to bring up at a later stage in the policy process.
I don't have an answer for you currently on that. However, there are many, as you said, downstream effects that this would impact. But for the mining industry in particular, those would be reopening previously remediated sites. But so yes.
Thank you very much for your comments. Appreciate it.
Thank you.
Next up, let me just circle back and see if we have Dr. Alan Prouty available now.
Yes, I am back. I'm sorry, my building was evacuated due to a fire drill. So
wow, well, kudos to you for adhering to the safety protocols. we understand and appreciate that very much. So we welcome your comment. You have 5 minutes.
Thank you. Yes, hey, good morning. My name is Alan Prouty, and I'm the Vice President of Environmental and Regulatory Affairs for the J.R. Simplot Company. We are a agribusiness company based out of Boise, Idaho. We are a vertically integrated company in the U.S. food supply chain, ranging from mining phosphate ore to make fertilizers, selling that throughout the United States. We grow a considerable amount of vegetables and raise cattle, and then have processing plants to turn those vegetables and beef into products consumed throughout the United States and the world, actually. The IRIS assessments, such as this toxicological review of inorganic arsenic, is of direct interest to Simplot because, as you just heard from the previous speaker, these assessments are used to develop water quality criteria, set drinking water standards, product quality requirements, and remediation targets. And so all of those are very relevant to our types of operations. Simplot has submitted a number of comments when there's been the opportunity to, and as mentioned by the previous speaker, it's been somewhat limited. So we've tried to take advantage of every opportunity that's been presented to put forward the comments for consideration by EPA and by the Science Advisory Board. I think fundamentally, I am not a toxicologist. My background's in chemistry, environmental chemistry, deal a lot with ecotoxicity. But to me, a lot of what this boils down to is when we think about the questions of toxicity of inorganic arsenic, it comes down to what is the risk to human health at these low exposure levels of inorganic arsenic? And is this risk a linear response to exposure, or is there a non-linear threshold dose response at these low exposure levels? And I think the reason I raised that specific question, and it's also in the written document I provided to that my verbal comments are based on is that, as the previous speaker mentioned, the background concentrations of arsenic in the environment are very relevant to how the toxicity values are applied in the regulatory world. So that's what I really primarily want to speak about. And I've got a table. Then I'm going to try to, hopefully, if this works, it says the host, though, is disabled screen sharing. So guess I won't be showing a table. But in my written document, which hopefully you have access to, there is a table which looks at the current either standards or guidelines for drinking water, water quality, and soils, either published by EPA or the state of Idaho. And then we've calculated what those values are based on the draft toxicological review that EPA has published. And then also in that table, I've listed what are the typical values, background values, natural conditions for inorganic arsenic in these various media. And it's primarily focused on the state of Idaho, as that's where we had the most data. And as you look at that table, and like I said, I'm hoping that table is available to you, what you'll notice is that
you can share
the calculated values. All right. So so hopefully, are you able to see my table?
No, we don't see it.
You don't see it. Okay,
we did receive your written comments, so
okay.
we can look at it there.
All right. So I will continue. I'm not sure what the problem is here, but I'll just continue onward. One of the panel members raised a question to the previous speaker about that the charge given to the panel is looking at what I'm going to call some of the toxicological and human health study information. So how relevant is it to what is called these downstream effects? And I guess the question that I would put to the Science Advisory Board is that when you look at the potential regulatory standards that will be calculated based on this assessment, there is a very large discrepancy between the background concentrations of inorganic arsenic in the water and soil and the calculated values necessary for the protection of human health. So from our perspective, that really raises the question of the validity of the toxicity values that are being derived for the protection of human health from this EPA toxicological review. And so I think fundamentally that is the issue.
Yeah, you're quite a bit over time. I gave you a little extra because of looking for your table. So are there comments from, or clarifying questions rather, from the panel? Okay, I'm not seeing anything. So thank you for coming back from your fire drill, and I'm glad you were able to have the floor here for a bit to present. So our next public speaker that we didn't find before, we'll try again, is Dr. Harvey Kluel or Kliewal.
Yeah.
Are you with us?
Yes, I'm here. Can you hear me?
Yes. Is it Kluel?
Kluel, yes.
Yeah, my apologies. Please,
no problem.
Go ahead.
Okay. Good afternoon. Almost good afternoon. My name is Harvey Kluel, and I'm a principal consultant at the Health Sciences Division of Ramboll, U.S. Consulting. I've been conducting research on pharmacokinetics and mode of action of inorganic arsenic for more than 30 years. I'm speaking on behalf of the Superfund Settlement Project and the RCRA Corrective Action Project, but the opinions expressed today are my own. I was greatly disappointed to discover that the new draft IRIS assessment for inorganic arsenic does not provide any evaluation of the evidence for its carcinogenic mode of action. Although the IRIS document states that mechanistic evidence was extensively considered, It only cites one publication related to the biological dose response for arsenic carcinogenicity. That paper was a review I wrote 17 years ago, but the agency used it to support a conclusion that the mode of action for inorganic arsenic is still uncertain. In fact, that was just a preliminary review conducted to inform the joint planning of a series of mechanistic studies that were subsequently conducted at the Hamner Institutes and at EPA. Many other mechanistic studies have also been published since then that support a likelihood of the threshold for inorganic arsenic carcinogenicity, and yet none are mentioned in the toxicological review, despite the fact that the current EPA cancer risk assessment guidelines clearly require the consideration of mode of action evidence in determining the appropriate dose response modeling approach. So the guidelines require it. Unfortunately, the draft toxicological review does not provide a sufficiently transparent description of the new and highly complex modeling approaches the agency has applied to permit evaluation of the agency's claim that the epidemiological evidence was comprehensive and sufficient to inform decisions about the anticipated shape of the dose-response relationship. I find that claim suspect given the potential for exposure misclassification and other error to distort the exposure response shape, as Kenny Crump pointed out in 2006. Most troubling, we were able to find our code in the recently released BMD modeling materials that generated plots that actually did show a comparison of model predictions of relative risk with individual study results that were, and these for inexplicably, these really useful plots were not included in the draft toxicological review, even though they demonstrate the variability, the actual variability of the study results around the model fits, in contrast to figures 4.7 through 4.13 in the toxicological review, in which they used, quote, summarized, unquote, study data, and in which the model appears to fit exactly like beads on a string. I just couldn't believe those figures when I first saw them. It's talk about non-transparency and anyway. So I will include this slides with a couple of the examples of those figures that can be generated from the code that we had to work through for in a short period of time in order to find out what was actually there, but would have been very useful to include in the document. Despite the publication of the current cancer guidelines in 2005, the only case where the agency has conducted a cancer risk assessment for using a nonlinear mode of action is still the IRIS assessment of chloroform in 2001. Since then, a number of EPA SABs and NAS peer reviews have suggested to EPA that an IRIS assessment for several chemicals, including dioxin and formaldehyde, several times, should be modified to objectively present mode of action evidence to inform dose response approaches, but the agency has not complied. I understand they believe it's too hard. Even if the ultimate determination is made to assume a linear dose response, the evidence from mechanistic studies should be provided objectively and transparently, as these are critical for a public understanding of the potential health effects following exposure to lower concentrations of arsenic, rather than fear-mongering. Thank you.
Thank you for your comments. Appreciate it very much. Any clarifying questions from the panel for Dr. Klual? Okay. Seeing none, I thank you very much for your comments. Next on our list of public commenters is Dr. Paolo Buffetta from Stony Brook University. I believe you're in the room. Yes, thank you.
Thank you very much. Good morning. So I am a cancer epidemiologist. I've been working quite a lot on occupational environmental cancer, including including arsenic. So can I have the next slide, please? So I prepared these comments just, on behalf of myself. I work a bit with the Arsenic Science Task Force in the earlier phase of the comment period, and I consulted with both industry and expert litigation for both plaintiff and defense in issues concerning arsenic. So obviously there are many aspects of the document that rose my interest and questions. Given the short time, I decided to focus just on a couple of major issues, very much related to the selection of the studies. So I will have a few examples. Obviously there is no time to go into all the details, and I really tried to do it as just for a purely scientific review type of point of view. So one aspect was the exclusion of the recent studies. And this has been a bit frustrating. I published a couple of dose response meta-analysis looking at data at low doses in the last couple of, 3-4 years. And these were not included in the review, in particular one on lung and bladder cancer. Similarly, there were obviously several other important studies, I think, that were excluded for the reason that has been discussed before. Some of the studies were included in somehow inconsistent way. I couldn't really understand. I just put one example of the lipolity study, which was mentioned already before. For some reason, this study was included in the review for lung cancer, but not the one for bladder cancer. And I couldn't really understand why there were these two different, approaches for exactly the same study, although the results were different for the two cancers. These are just a few examples, obviously. Can we go to the next slide? I think we can skip this one, which has been discussed a lot, really about the low dose extrapolation from high doses. I just want to stress what we try to do in our meta-analysis. If you go to the next slide, and as you see, I tried to link my comment to specific charge question to the extent which was possible. So what we did, in particular for the lung and bladder, was really to do a meta-analysis based on linear extrapolation for the studies which presented results at low dose, which means up to exposure levels of the order of 100 or 150. We tried, several things. And this was using only the low dose data. And if I can have the next slide, this is just the results of the bladder cancer studies. This is just a slide from our paper, and this is the midpoint for each exposure categories. And there were about 8 or 9 studies of bladder cancer, both case control and cohort studies. You see some of them extended up to about 100. And some were restricted to lower doses in the 20-30 microgram per liter. So the next slide is just another slide from another figure from our review, or just a very simple meta regression. I mean, the meta-analysis of the regression lines. This was for bladder cancer, but the point was really that in our attempt, we tried to be as transparent as possible and reported all the doses, all the categories, all the reasons for excluding each individual study. And this was not so easy to find, in the IRIS document, which left me a little bit frustrated. So we can go to the next slide. Just to move to another example is diabetes. Again, there is not much detail, not too many details on why some studies were included or excluded. But for diabetes, it would just mark that, basically all the high dose and the low dose studies reported an association. But in fact, if you look carefully at the studies on diabetes with low doses, this is not so true. There are studies showing an association for sure. For example, the Mendez study, the study by lipolity again in women, etc. But many of them did not really show an association at low doses. I mean, they don't show trend. They don't. So I haven't done a formal meta-analysis yet of this data, but I was a bit surprised, and somehow again I couldn't go into the detail and understand what was the rationale for the selection and the conclusions in the IRIS document. So the next slide, I think I have one more. Well, okay, I think we can skip this one. Was about for CSF. There were exclusion of high dose, but this has been discussed. Finally, for the neurodevelopmental study, also, which, okay, is not one of the key points, but again, for some reasons, and the discussion in the document is very short here, it's really very short. And for some reasons, there were just two studies, one in Bangladesh, one in the US, which were retained. Again, one is high doses, one is low doses. And the conclusion was, I just took it that based on the studies of with low doses, there was an association or deficit, whatever, for cognitive and behavioral events or conditions. And yet, in fact, there was absolutely no results on behavioral assets. So I think I've done. Thank you.
Yeah,
Thank you very much.
thank you. Thank you. I wanted you to get to the end. So are there clarifying questions for the speaker?
I have a question. I raised my hand online just because I am not sure if you can see my hand in the.
I can see your hand and I can see you now. So go ahead, please.
Wonderful. Thank you, Dr. Buffetta. This is very helpful to see all your comments. I have a question about the diabetes table that you showed. I understand that you put together that table and you mentioned like no association in some cases. But if I recall correctly, for some of these, how did you interpret no association?
Yeah.
Because
well, yeah, no.
I think one of the issues of this pulling together evidence is that we don't want to necessarily do it based on a statistically significant thing, but more like looking across the board of all the studies together. And if I recall correctly, maybe some of the studies might not necessarily be classified as no association. So I wanted to understand how did you came out?
Yeah, no, sure. This slide was extremely succinct. I had to. I was just focusing on the results at for exposure doses below 100 microgram liter, really. And when I saw no association, I basically said that there was, well, when there was some trend, but not significant time market, when there was no association, meant that really the slope was not different. I mean, it was basically one. So that's really what, but I agree, we should go into more details on that. I was just really trying to stress that I don't think the evidence for diabetes at low doses is very strong or very consistent. This was my main point.
In your 2019 review, you included a number of the papers that were also screened and included in some cases by EPA. So I think you were concerned that the 2019 paper wasn't included in the assessment, but the meta-analysis you did was many of those were included in what EPA has done. Can you comment on that?
Yes, but for our meta-analysis, we derive slopes for each study, even if if the original papers did not present it. And then we meta-analyze this, which was it was a different approach compared to EPA. So the same studies many of the studies were also present in EPA, obviously, but we use a different approach to summarize the evidence.
Thank you for clarifying that. Okay, thank you very much for your comments and your time. Appreciate it. So our last registered public speaker is Dr. Nick Skoulas from STEPTO, speaking on behalf of the Arsenic Science Task Force. And I had that you were in the room, but you were remote.
Well, unfortunately, some things had come up and was unable to make it down, but I thank you for allowing me to present some of my questions, as well as I'll be reiterating, which many of those speakers before me have already laid down. But I'm a toxicologist and currently a senior consulting toxicologist at Steptoe & Johnson out of the Washington, D.C. office, and have been working with wood preservatives and inorganic arsenic since 2002. So the issues or questions that I have more prominently here is to deal with the mode of action. Next slide, please. and which many have talked about the mode of action. There is clearly evidence of the mode of action as being demonstrated with inorganic arsenic, and not only in intact animal models, but in vitro, which has been discussed, and some of the difficulties in extrapolating those in vitro studies to humans. But obviously the work that Dr. Buffetta has done has clearly supporting the proposal of a mode of action. And I think a lot of the mode of action data is very important to provide that biological component that Dr. Beck had discussed as well. And pretty much the mode of action is the interaction of the trivalent arsenicals that interact with the sulfhydryl groups in critical proteins of these cell tissues. And many of these discussions and papers that have been published prior to the cutoff of 2015, Kitchen and Wallace in 05 and 06 and 08, Cohen in 2013, Suji in 2019, but one study that Dr. Klool et al. In 2018 also had the same mode of action interactions with sulfhydryl groups in critical proteins. The proteins are regenerated fairly quickly, and this mode of action involves these damaging reactions with these critical proteins. And it gets to a point when the concentrations of the trivalent arsenicals increased above that rate of regeneration. And that leads to the fact that it's a threshold. And you saw some of the data that was presented in Xiao's presentation, and pretty much is what I had seen in his publication of 2021, that there is a threshold when they're looking at the different models. So I think it's very important for the SAB to really consider a lot of these points. Next slide, please. And again, there's been a lot of talk of mode of action and mechanism of action. I think it's important to, really distinguish between the two. And the mode of action is an interaction, as I mentioned, with these trivalent arsenicals, with these critical proteins that are has sulfhydryls in those proteins in the target tissues, because this leads to cytotoxicity and the regenerative cell proliferation. And there is only one mode of action, and it is threshold. But interesting enough, these interactions with the critical proteins lead to those mechanistic endpoints that Ira speaks of: oxidative stress, and other effects that all can be brought back to one mode of action. So I think this is important to consider. And again, Ira summarizes their explanation for not incorporating the mode of action. And again, it's entitled Mechanistic Observations. And that they indicate that they've considered the mechanistic approach for each endpoint. And they go on to indicate that this is a linear and non-threshold, especially at the low dose. And again, no mention of the mode of action. Next slide, please. And again, a lot of the work has been older citations, as a point out here, and that again, what at least didn't appear that they've accepted the mode of action, from the previous work from 2008 and 2010. And Jaeger's work in 2014, Cohen's in 2013. But Klool also has presented as a study in 2018, as well as Suji in 2019. And then the movement also going through the Buffetta's work, which sort of all puts it all together. So I really hope that they look at these studies a little bit more clearly. And I'm sure that people like Kanchao and Harvey Klool would be happy to answer any more questions, as well as Dr. Samuel Cohen.
Okay, thank you. You're at time. You're over time. Thank you. Appreciate your comments very much. And I see that we have clarifying question from Dr. Pessa and another from Dr. Gribble. So Dr. Pessa, why don't you go first?
Well, it's probably better categorized as respectful disagreement. Proteins don't have one half-life in the body or in any cell. Protein half-lives span from a few hours to hundreds of days. Many of these proteins respond to local redox potential, and so the terminal mechanism is not sulfhydryl modification, but conformational changes. This can have dramatic effects on mode of action, which you define as physiological effects that can span long after the modifications have been made in conformation. So I think that needs to be accounted for, in particular in tissues that do not divide, such as those of the brain neurons and of the heart, cardiomyocytes.
Well, thank you for that, and interesting too on the work that Clue et al. Discuss in their 2018 paper with the vicinal proteins, with the diethylsulfhydryls, that the oxidation of those sulfhydryls, does lead to some of these effects. And do you consider that as part of the because it is a conformational change of the protein? It's sort of it is an oxidized sulfhydryl of the vicinal protein, which they're two carbons apart from the sulfhydryls, which they become oxidized. And from what I can see, that is, they list that as a conformational change. But point is well taken.
Let's go to Dr. Gribble's comment.
Yeah.
I have two comments, and thank you very much again for these thoughtful input you're providing. The first is that although a full discussion of the mode of action would be, well, beyond the comment verbal period we have today, a really important dimension of arsenic toxicity is the epigenetic modifications that arsenic induces, which would not be a threshold toxicity dose response in general. So that is just a first point. Is I think that the toxicology of arsenic is very complex and multi-mechanistic. And one of the advantages of relying on observational epidemiological evidence is that it's sort of mechanistically agnostic and looks at the totality of what do we see in humans rather than more myopically focusing on a single proposed mode of action that might be insufficient for accurately describing the full risks posed by arsenic. A second point, which loops back to an earlier comment about comparing the EPA's methodology versus the JECFA, the Joint Expert Committee on Food Additives of WHO-FAO. The choice to integrate multiple studies and multiple lines of evidence in EPA versus relying on a single key toxicology study for benchmark dose derivation has this advantage, as was highlighted in the previous comment, of not only relying on a positive, negative vote counting meta-analysis, but actually getting at overall in the total weight of evidence, what are we seeing as the pattern of relationships? And with something as complex toxicologically as arsenic, there's real value in that. And that's a little beyond the charge question, so I don't know if we were going to get to that later in the discussion, but I just really salute EPA for taking on this highly rigorous, highly integrative, highly transparent process that is more toxicologically inclusive.
Well, thank you for those comments. I would like to just make a comment pertaining to your epigenetic comment. I don't think there's any question that that inorganic arsenic is associated with the cancers and or diabetes, but I think that there has been some discussion on whether or not inorganic arsenic is indeed interactive with DNA. And I know that there was a previous study that had demonstrated some micronuclei that had been paper discussed where that may have been in artifacts. But one of the key issues with these interactions with these proteins, the sulfhydroproteins, is the fact that it basically can block the repair of these potential effects on DNA. But I don't think anyone in the room or anywhere on the phone would argue that the effects are complex with inorganic arsenic, but I just think that there's just a lot of data there, and I just hope that we can look at it and give it the most appropriate attention, which also goes to Kun Xiao's discussion on the logistics model, which when the fact that it wasn't as flexible, I just wanted to point out that those low doses would tend to flatten out, and that may not look as significant as it does, in those models. But
Okay.
that's all I have to say, but thank you again.
Thank you very much. I appreciate your comments and you're taking the time to share those with us today. So that is all we've heard from all who have registered to speak as public commenters at this meeting. And we are at a time when we were scheduled to have lunch. We're actually about 10 minutes over, but we left a little extra time for lunch. If we could convene at 1:15 local time, that's just a little over an hour from now. That would be terrific. And then we can begin the next phase of our work. And let me just invite the DFO to say anything if she has any comments.
No comment. We can go for lunch.
Okay, so she's hungry. All right. Thank you, everyone. We'll see you at 1:15 local time, Eastern time.
Yeah, 3 hours.
For those in the room here,
It's just for the panel.
yeah, panel lunches are across the hall. Hey, we're at 1:15. So I'd like to move to our next agenda item, which is discussion of response charge questions. And we have very non-arbitrarily decided to start at question number 1. I'm surprised there. And our lead discussant on this is Dr. Navas-Essien. We also have Dr. Gribble and Dr. Karagas. And I just want to, seeing your slide there reminds me that as we go through these, we're not assessing tier level for these at this point in time. We can certainly mention that, that's not a problem, but the tiering process will come when we complete all of this and we collectively look at the number of recommendations and suggestions we have and decide how we're going to tier those. But it's okay to mention it, but just know that the process will take care of that at a later point in time. So with that, I guess I'll, oh yeah, one other thing. I want to just have Dr. Sylvie Bruder introduce herself. She was not able to be here this morning because of a conflict with another meeting. She'll be with us this afternoon and then online tomorrow and Friday. So Dr. Bruder.
I depress to speak. Thank you. Yes, I'm happy to be here. Sylvie Bruder from Purdue University.
That's the most succinct introduction we've had yet. So good job. Yes, and so here comes Dr. Gribble. So why don't you go ahead with your lead discussant review. Go ahead.
Wonderful. Thank you. Yeah, first of all, yeah, this has been a very insightful process so far. It was really a pleasure to read this comprehensive effort, the IRIS assessment for inorganic arsenic, toxicological review for inorganic arsenic, and also to review the comments and the discussion and the process so far, the public comments. I think it's very helpful to get all of these perspectives to help all of us to do the best job possible with this huge effort. So I was able to read the response that my colleagues prepared as well. In addition to Dr. Gribble and Dr. Karagas, also Dr. Wyckoff also prepared some comments to this question 1. So I am going to summarize more or less, and then of course I will let them add anything in addition. It seems that in general we are kind of in agreement that the IRIS toxicological review of inorganic arsenic has been highly responsive to the previous recommendations, including the 2013 National Research Council committee and the NASEM committee in 2019. So the IRIS review has focused on epidemiological studies, a breadth of databases to identify those studies. There is a good description of the population exposures, comparator outcomes. There is a focus on the chronic exposures. There is an inclusion of studies that have either data on environmental exposures, like drinking water most of the time, or studies that have biomarkers of exposure. And personally, I believe that that's an adequate way to deal with this very, very complex issue. Different studies have different biases, different weaknesses, but the weaknesses and the limitations are different for environmental samples, drinking water assessment versus the assessment of biomarkers. The limitations are different, the weaknesses are different. So when you see robust findings across those different types of studies, I think that gives us a little bit more confidence that we might be capturing a signal that is beyond the individual weaknesses of the different types of studies. So that's why I believe that the approach the EPA has followed of including both the studies based on drinking water and the studies based on biomarkers is appropriate. The list of outcomes, I think most reviewers, we were in agreement that it's an appropriate outcome, a list of outcomes based on the original recommendation, as well as the evidence that has been available and identified through the process, although there could be some discussion and argument, and I believe the reviewers had also additional recommendations in the different sections that is probably better to do in the specific sections rather than in this very first charge question. I had a comment myself about the PBPK analysis, because it said it was included among the PICO criteria, but clearly it didn't follow the PICO criteria. So at this, I thought it could be simpler to put that on the side rather than to try to make it fit on their PICO. But that's a very small comment, more cosmetic or than anything else. I felt I really want to congratulate. This is a huge effort. I think all of us we recognize it of so many years, and it's a real treasure for the field, for the future, for the current, for now, for today, but also for the future, to build this massive compilation of studies, of research conducted in so many different settings with so many different conditions, and to have everything together in a single document, in a single effort. It's a real treasure, which is going to help in many different ways. The systematic review process is carefully reported. It was carefully done, including multiple reviewers. There was, of course, very complicated to do because there were different stages, and there is the effort that was done by 2019, and then there were the updates done by 2022. And it seems that it was decided that only when the evidence had been more modest and papers could be augment that evidence, they were included, or for the dose response, because that was really helpful to have more data. And maybe reviewers could disagree here. Should we maybe ask for a full inclusion and update, or maybe not? I personally think it's okay, especially for the hazard identification. It's okay if it's not going to change things. Maybe not necessarily to update it, although of course it will be more transparent, more clear, more complete if it could be updated. So that could be debated. So overall, the number of studies has been really impressive, and I don't have any specific comments in this first session. I have specific comments for different sections of maybe studies, that why are they included or not included sometimes. So I think that's a reasonable exercise to go for the individual sections, but not overall. I think from the comments from the other reviewers, I think from Dr. Grubel comments, I feel that there was very consistent with my comment. The inclusion also, he highlighted about the inclusion of the susceptibility factors, genetics, arsenic methylation capacity, and that was also a very appropriate thing to do. And then there were some smaller comments regarding also details of how to better document or present. From Dr. Karagas, the same, very pretty consistent. I think overall, I think maybe one comment of maybe I think I understood from Dr. Karagas' comments to update the literature would be preferred to be more complete. And maybe also why some outcomes that have been recommended by the NRC and NASM committees were not necessarily included. So that maybe but that also that could be covered in later sections. And as I mentioned, Dr. Daniel Wyckoff also provided some comments to this charge question 1. And it was related to the PICO system, and that this maybe remain ambiguous of the non-PICO studies, okay, that why some of the studies that didn't meet the PICO, I don't know if this is maybe related to the pharmacokinetic studies also, as I mentioned earlier myself. and then some outcomes based on the cost benefit, and to have more description based on that, and then something related to the graphics and narratives. Okay, so I would like to invite the reviewers. I don't know exactly what the process is. Sorry, because I am the first one through this, and I am not sure if I am doing what I was supposed to do. I hope so. So if I can get more help from the chair of the committee, and I am supposed to invite the rest of the reviewers to comment on anything else they would like to add.
I'm happy to do that. But I'm not, don't need to do that. But in this case, since we're there, I'll do that now. And so Dr. Gribble and Karagas, you want to decide between the two of you who wants to go first? Okay, Dr. Gribble.
Thank you, Dr. Navasassian. I think you summarized very well most of my preliminary comments. One thing I would just emphasize, which will come up again in charge question 4A, is there have been a number of public comments and some comments by members of the committee that additional transparency and documentation of inclusion-exclusion decisions would increase transparency of this process. I feel that this has been overall a very transparent process about the decision-making for rules of inclusion or exclusion, but for specific studies, it might be nice to know why that study was deemed relevant, high reliability, irrelevant, et cetera, just to kind of make it easy to follow for a reader.
Go ahead, Dr. Navas, or Dr.
Thank you so much. I thought that was an excellent summary by Dr. Navasassian and covered everything that I had written. And I also agree that some of these issues may be better addressed as we get down into the weeds in a little bit more with the specific outcomes and different model decisions, et cetera, for the later charge questions. So I think for now, I'm happy with the summary. Thank you.
Okay, so I see Dr. Wyckoff is ready to speak, so go ahead.
Thanks. Yeah, maybe I could just expand a little on the PICO comment. So it doesn't specifically relate to the inclusion exclusion, but just an observation listening to the comments today and thinking more about all the other SAB member comments is that the IRIS program really is one of the leaders in using systematic review to facilitate risk assessment. But I think we all recognize these methods are really still evolving. And as I've thought more about a lot of these pieces that we've been talking about in the future, it may be helpful to have an actual PICO statement question, sets of questions that really help to state what the objectives are. And I say this because, I think that so far these methods have really aligned up through hazard characterization, but we're seeing such a critical importance of candidate study selection, mode of action, things like that. So to have a research question that's specific to, are you assessing causation? Are you assessing dose response? And then being clear as to, maybe even specific outcomes to the extent possible. Having a clear research question would also help address some of these PICO studies that were, that were tagged as supplemental or contextual and how they were used. I also did want to make a comment that I wasn't entirely sure if some of the risk modifier studies, how those related to the PICO, the inclusion, exclusion, the studies, the general approaches. And I do think it could be just clarified when different searches were done, particularly for those. And I do think that's important because the agency says that those are going to be anticipated to be used by future assessors and cumulative risk assessment, et cetera. So having an understanding of those risk modifier, the studies underlying those risk modifier tables, I think will be helpful.
Okay, thank you. Anything from other members of the panel with regard to charge question 1? So while you're thinking, I just wanted to mention that, I've seen sort of the evolution of a number of these as the whole methodology around systematic review has been evolving, specifically systematic review for environmental hazards as opposed to, say, clinical trials for pharmaceutical agents. And in a number of cases, it was sort of a lot of the assessment had already been done, and it was a matter of doing sort of a mini systematic review. And I think in this case now we're seeing one where there had been a lot of work prior, but now there was a systematic review that was done under the handbook and the accepted methodology that has evolved. So I think it's worth commenting that although we have comments that pertain to the systematic review and the PICO statement and the selection of informative studies, that this really does represent an advance of the whole area of risk assessment. And then there's also this question about the timing. Do we include a study from December 2023, or do we include a study from, draw the line wherever you want? At some point, if you don't draw the line, you're never going to get to the finish line. And yet, as we think about it, there will always be a movement forward of an advance of the science, and the process allows for inclusion of additional information as it comes. This will be coming up in decades ahead. And so I think we just have to recognize that the agency, and IRIS in particular, has to draw a line somewhere, and we can't continually worry about that. Now, where that line is and what's practically feasible for them to get a document to us by this time for review is probably something that we can think about, but there has to be a line. And I think I just wanted to acknowledge that we recognize that. This process has been a long one. And so there has been a lot of new studies accumulated since 2000 that have been very influential, and we see that in the document. So I'm happy to see that has happened. So, yes, Dr. Gribble.
Just a brief note, they updated the systematic search in 2022. So at least for the epidemiological evidence, I feel like it's quite current.
Thank you. Other panel members or anybody on the panel? Yes, sorry, Dr. Karagas.
I just wanted to make a clarifying point that I think the comment was, yes, they did update the review and then selected which articles would be included in dose response or et cetera, based on, whether they would change the assessment and things like that. So the point was made, should we consider that updated review more uniformly throughout the report or not? So I just wanted to clarify that, but certainly your point is well taken. There's got to be some stopping point. And so the stopping point, I believe, has been made. It's just how to handle that updated review that's been brought into question. And again, we can cover this later.
Yeah, thank you for that. Okay, I'm not seeing anybody else expressing an interest to speak on one. So I think we can move to question 2A. And for this, we have Dr. Barchowski as the lead, and Dr. Karagas, Pesa, States, and Wyckoff also contributing to this. So Dr. Barkowski, is it, sorry, Barchowski?
The latter is correct, Barchowski.
Okay, thank you. Sorry, I got that wrong.
Okay, thank you. And thank you for including me in this panel. Again, we're doing very important work here. And I think that we can really make some major contributions to improving the assessment and making it a great document. In the charge question 2, we were asked to comment on whether the study confidence conclusions for the inorganic arsenic studies are scientifically justified and clearly described, considering the important methodological features of the assessed outcomes. please indicate any study confidence conclusions that are not justified and explain any alternative study decisions. So overall, I'd like to start out by saying that we think that the EPA did an incredible job with this work. I echo what Dr. Navasasian was saying about transparency and that we feel that there is quite a bit of confidence in the conclusions that were made. The this is inclusive of both the cancer and non-cancer endpoints, but as arsenic being a known carcinogen, the weight of evidence there wasn't as important to evaluate, but specifically in the non-cancer disease endpoints, the accumulation of literature, the use of the Hawk system to go through that literature and look at how the papers were categorized really provides a lot of transparency on the selective articles and categories to which they were assigned. The individual study evaluation ratings and the rationale for the ratings can be easily viewed for the studies that met the criteria and of medium and high confidence. The criteria used to assign risk of bias evaluations and confidence ratings are also clearly presented. Not all was perfect, and there was some concern. It was expressed a little bit earlier that the search strategies were not completely intuitive, and a number of the reviewers found it difficult to find the low confidence or non-confidence papers to be able to evaluate. And so this led to a number of comments from my colleagues that really related mostly to not having enough time to try to find those confidence papers, those low confidence or uninformative studies, and evaluate why they were excluded. So the suggestion is to improve the search strategies or improve the accessibility of the programming. And a related comment is that there is an incredible wealth of studies in Hawk, and the committee felt that they really didn't have sufficient time to give full review of the individual studies to appreciate whether the EPA approach and protocol was truly appropriate. And the, sorry, I lost my mouse. This is especially true for not being able to see the ones that were excluded. While the study confidence rankings are justified and reasonably described overall, the determinations for risk of bias, which in turn could impact the confidence ratings, need to be more carefully assessed. There were a lot of questions here by the reviewers, and I'm going to defer to them because it's not my area of expertise, but a number of questions were raised regarding how the EPA actually was evaluating risk of bias. One example, a study may not have adjusted for appropriate covariates. I believe Dr. Wyckoff already said this a couple times, or considered it as a potential confounder before it's in a causal pathway. To the issue of methodological importance, Dr. Pessa raised concerns about whether or not the EPA evaluated the quality of sample collection and analysis or variations in sample collection that might present both a potential bias, but also cause a variation in dose and biomarkers, and I'll allow him to elaborate on that. An important issue raised with regard to confidence, actually, in listening to many of the public comments, it kind of comes back to whether or not there could be more confidence, especially in the cardiovascular assessment, if mode of action and mechanistic studies were actually included. I mean, following the NRC 2013 and the NASM 2019 recommendation to only include epidemiological data, appears to have weakened the conclusion somewhat that there is evidence that demonstrates that arsenic causes disease of the cardiovascular system. There's the inappropriate bias in the report that, and also with many of the comments that were made from outside, that animal models are not reflective of human data and that rodent models are less sensitive to adverse effects. This actually is not true for cardiovascular. It is true for cancer. And it suggested that perhaps mechanistic and dose response assessment could be done to show plausibility. And I'll specifically mention that you can look at the cardiovascular endpoints from the epidemiological studies, such as atherosclerosis, endothelial cell damage, or inflammatory marker generation. And if you look in the mouse literature, there are studies that show that the threshold for atherosclerosis in a mouse model is 10 micrograms per liter or so. Vascular remodeling and endothelial cell dysfunction are observed with thresholds between 1 and 10 micrograms per liter in subchronic and chronic dosing. Likely mechanisms and mode of action have been shown that essentially reactive oxygen species generation modifies styles and also decreases the availability of nitric oxide for vasodilation and health, all through plausible mechanisms. Again, shown in vivo with dose response curves that are quite comparable to human exposures. Human relevant dosing gives pathologic markers in the plasma, such as asymmetric dimethylarginine, and that's known factor for cardiovascular disease risks in humans. And there are human epidemiological studies with arsenic showing changes in this risk factor for cardiovascular disease. So essentially, there is a wealth of studies that range from 2005 to 2018 that could be used to do mechanistic mode of action type analysis. And by doing this, it might be that we can move towards having a much stronger confidence in the determination of causality as well as plausibility and also confidence in the reference dose for cardiovascular disease. And I'll leave it at that from me because the expertise of the rest of our group can really address specific questions.
Okay, thank you very much, Dr. Barchowski. So let's just go in the order, which I guess is alphabetical. So Dr. Carrigs.
Thank you, Dr. Barchowski, for the summary. I'd just like to elaborate a little bit on the two comments that I had made. As Dr. Lee told us, it is possible to see those other studies that were low confidence or uninformative, but they're not in the little table, the nice table that appears in the draft where you could just click on the square and get the information. So if my understanding is correct for myself and a couple of the others, that if those kinds of tables were available in an appendice or supplemental material, it would have made it a little easier for us to go through those studies. So that was the point, and others can clarify if they had a different perspective on that. And again, so we are able to see the justification very easily. But there were just a few things that I noticed clicking through the comments. And one, as Aaron mentioned, that a study might have been downgraded because they didn't adjust for a particular covariate as a potential confounder. But it was a variable that was in the causal pathway, so you wouldn't want to adjust for it. So it would be inappropriate. And I think this will just come up as we talk about the individual outcomes. I don't know how frequently that occurred. I just noticed a couple examples. And then another example I noticed was that studies of urinary arsenic might have gotten downgraded because they did not adjust for seafood intake. I read that in one of the comments. But if it did speciate arsenic and excluded arsenobutane, you wouldn't, I think, ordinarily downgrade a study because they didn't adjust for seafood. I guess that's debatable, but that's, I think, a pretty typical practice. So those are just a few comments.
Okay, thank you. Dr. Pessa, you can go next.
Yes, thank you. I also commend EPA for doing, I think, a heroic job of pulling all of this together, this huge number of studies. The question I had is, given that they pooled different studies into dose response analysis, it seems to me if there were any minor divergence in sort of a standard operating procedure for sample collection, sample handling, sort of chain of custody type issues, that might lead to either minor contamination of the samples or in storage. Some samples are stored for years before they're analyzed. And with arsenic, given that most measured a metal, I'm not worried about degradation, but you really have to be concerned about volume changes. Not all samples are stored in the same kind of receptacles, and there's no real comment about whether samples were stored at -80, whether they were stored at room temperature after acidification, and there's probably a whole bunch of ranges in between those. So that, was a concern for me. Not that they could probably get that information unless it was specifically stated in a paper, but there should be some reference to potential variation in the actual key measurement, which is either urinary arsenic or either creatine corrected or not. And so most of the studies were conducted blinded to the team, but not all. And in particular, I found this to be a particular issue, unless I'm missing something, in the Wasserman 2014 study, which was unblinded, and how that might impact. But we can discuss that later. Again, I found that addressing mode of action may be very helpful at some point in the future, primarily because the 4 health outcomes are not independent of each other. That some of the very same mechanisms that are known to affect cardiovascular disease initiation and progression have also been identified as mode of actions for initiation and progression of some central nervous system, as well as, of course, how diabetes influences cardiovascular. So how these interact with each other when they're separate studies, I think, should at some point receive some attention, even if one can't get data of both or more than one outcome from any given study. I think that's it for the major issues. The others have been addressed just fine.
Okay, thank you. Dr. States.
Yes, thank you. So I agree with everything that's been said. I think that the EPA was very responsive to the 2019 recommendation of if they have a broad enough range of epidemiological data that MOA is not necessary because they're not going to be extrapolating. But I think if they were to evaluate, as I mentioned earlier, more recent mechanistic studies, and as Dr. Pessa, I think, alluded to earlier, not all sulfhydryls are created equal. So there are exquisitely sensitive targets that were heretofore unknown until people did the low dose studies. And that not using the MOA for extrapolation, but perhaps the agency might find that they can strengthen their arguments with these more recent low dose studies, both in the cancer and non-cancer endpoints.
Okay, thank you. Dr. Wyckoff.
Right, thank you. So I think my comments are really about the methods. So the charge question is about the systematic review methods. And I think I'll just expand a little bit on the study evaluation specifically. So, in looking through the data, and I did find as well the low and uninformative, they are kind of categorized differently within HAWK, which I think did add to just some of the complications in finding them. And I do echo that having some heat maps that show all of the data together would be helpful, because within HAWK, being able to click for a given domain and then look across the studies is incredibly helpful. So that's really nice that that was there for the medium and the high studies, and it made it really easy to see. But when I think about the study evaluation just in general, I do have some concerns that the evaluation was not sufficiently critical. This step is by definition systematic review, called critical appraisal. And we are doing a risk assessment here. And so it is my opinion that the studies need to be assessed in context of appraising them for risk assessment. And with respect to the observational data in particular, I think we all recognize that there are differences in those types of data versus treatment-related experimental studies. That's very well established. And so if we're going to use risk of bias techniques and look at internal validity based on kind of the epi study design, there still needs to potentially be another step for sufficiency and risk assessment. And I do like that this assessment has added that step by having those criteria. However, I did find it concerning that in the subsequent sections, when they're talking about reviewing for those dose response criteria, many aspects of internal validity are actually brought up as reasons for not including those studies. And so I do have some concerns that if there were issues with some of the domains within internal validity and risk of bias, that those should have been accounted for in the risk of bias assessment originally. So it looks like there are some inconsistencies between those two applications. I also think that it would have been helpful to a priori do additional refinements to the risk of bias criteria to be specific to the assessment. So the protocol does give some good information on some of the domains as it relates to arsenic, but there are largely no outcome specific refinements as to related, whether it's covariates or how you're looking at the outcomes, et cetera. And that's really important. When you go to look at systematic reviews in the literature and guidance, even OHAT, which is what's cited by IRIS here, in indicating that that was the guidance, that they talk about doing these refinements, and they really are important. I am not an epidemiologist, and so I think you'll hear from some others how those things may impact some of the decisions down the road. So I would really make that recommendation going forward, that these are more critical in terms of how they're going to be used in the risk assessment. Or if you want to continue with the kind of the approach taken here, that these additional criteria are really specific to risk of bias, are specific to risk assessment and having confidence in that exposure outcome relationship. Then I also wanted to make a comment that I think one of the challenges in looking through the study evaluations is that they were done at the study level. So when we're thinking about then how these were applied in risk assessment, it was a little hard to follow what was done on for an outcome specific basis, particularly if the study looked at different outcomes or endpoints that were evaluated. And some of those domains, some of those assessments were only specific to a given outcome. So a more granular assessment of the study evaluations may also be helpful in the future. And then I think that also carries forward even to the data set used. So in this morning, when we were talking about, which data sets were using the actual dose response modeling, some of those risk of bias categorizations only applied to some of those data sets, but not all. So it was kind of hard to follow if the data being modeled actually had a low risk of bias, or it was just a study, if that makes, I hope that that's clear.
Okay. Thank you very much. So we've heard from the lead discussant and other members of that group. Anything from panel members? I have a question that maybe I can lead off with, just to clarify something. This is really in response to your comment, Dr. Pessah. When you think about issues like sample collection, handling, storage, tracking volume changes over time in the biorepository and such, I mean, all those basic QA/QC. Certainly when I'm a peer reviewer for studies, I look carefully at those issues and ask questions about those. So I'm thinking that a lot of that would have been handled, should have been handled in peer review, especially at the higher end journals. And then with regard to the volume reduction, I mean, I know I have a large biorepository in my lab, and we track the volumes when they go in and when they come out, and make sure that if there's a change, we account for that. So do you think that that this is something that EPA needs to try and do beyond what the peer reviewers should do? And oftentimes, as I think you mentioned, those, it's going to be hard to assess that after the study's published, unless it's one that has data in a repository. So can you comment on that? Dr. Pessah, can you comment on that, please?
Oh, yeah. I'm sorry. I cut out for just a few seconds and had to redial in.
Do I need to repeat what I said? I'm sorry. Did
Yes,
you hear what my question?
Yes. Please.
Okay, thank you.
So I brought up that issue because I do not believe that all journals that publish epidemiological studies have some standard of rigor, the same standard of rigor, I should say. And this is not accounted for, even addressed in the EPA document. I think for being realistic and wanting full clarity, some statement about the diversity of peer-reviewed journals that are being included in analysis would be helpful, I think, to everyone.
Okay, thank you. And then I also wanted to clarify something that you said, Dr. Wyckoff, and maybe I lost track at the moment, but you said something to the effect that studies are not included because of difficulties or problems with the internal validity, and that this was assessed, and that's a bad thing. So I missed something there, what you said.
Yeah, let me clarify. So no, assessing internal validity is a very good thing. And so this was done essentially in some ways at 2 points in the assessment, as far as I can tell. Really under study evaluation is the main place that they're looking at this. But as I understood the assessment, there are some pieces, some domains of that are then again considered at the dose response. So there were, let's just say 15 questions, and some of those were selected as being very important in the dose response assessment. And I think that makes sense, certainly. But where I had concerns is when you read when they looked at those aspects the second time, that they were issues with internal validity that should have been accounted for at the beginning. And those studies were rated as high or medium, yet when they looked at them later, they said, well, we can't depend on this in dose response. And I think that there's a logic disconnect there. If they're not good enough, then they shouldn't have been good enough at the beginning. And by good enough, I mean for risk assessment. I want to be really clear that we have challenges in using these type of data for risk assessment. So this doesn't mean they're bad studies by any means. We need to just say, how do we best use these in risk assessment? And so starting with qualitatively characterizing the risk of bias is really important. So then you can accommodate that later in the risk assessment. And so I think that's really my comment, that if they're not good enough at the end, then we should have accounted for that at the beginning as well.
So when I recall Dr. Thayer's presentation from the previous meeting, there's this notion that systematic review is a linear process. And there isn't an arrow that goes from that point back to what you're suggesting. So you're saying that arrow that goes back to the grading of the studies isn't existent and should be.
Well,
can I say, oh, sorry, can I say something briefly, maybe related to this?
Yeah, go ahead.
Because I think, well, in principle, I agree, if a study, but one element that I think we might be missing here, and I think this is why we need to go carefully about all the studies and the steps, is that sometimes you need additional criteria for the dose response analysis. And so a study can be very good for hazard identification, but you might not be able to include it in the dose response analysis because there was not enough information to characterize the dose response. And so it's not a surprise to me that a study was included for the hazard identification because there was enough information for that step, but there were not sufficient information for the dose response. That doesn't mean that the study has been downgraded. At least that should not happen. I think the study should, I agree, should be considered of adequate, sufficient evidence for hazard identification. And the reason for excluding them for the dose response should be related to the dose response criteria, not to change the grading of the quality of the study. And so I think if that has been done in that way, I have confidence about the process. So I just wanted to clarify that. I have another comment with respect to the comment from Dr. Pesa, but I'll stop because I don't want to interrupt the discussion that was about this quality of the evidence for the dose response versus hazard identification.
Okay, we'll come back to you then. Thank you.
Can I just clarify? Sorry.
I just want, I know Dr. Barton sort of raised it, but then pointed to. Okay, all right, go ahead, Dr.
I just want to maybe give one of the examples that I think caught my attention here, because I appreciate what you're saying, and it's not black and white, and I definitely understand that. But one of the descriptions, just as an example, was on the Wasserman study. There was concern both related to the exposure, but also that they didn't look at a co-exposure of lead, and these are very important risk of bias components. And in fact, the agency goes as far as saying the impact, the actual response that they see in that study could have been explained by lead. So that's that is direct evidence of a risk of bias. And the reason that you're not algorithmic, in using risk of bias is because you need to understand the importance of each of those domains. So here at the end, the agencies decided that study was not sufficient, essentially was not reliable for how it was being used. Not saying it's a bad study, just for how they're using it. And in my opinion, that should have come through. That should not have been a higher medium quality study to begin with, if that's the case.
Okay, Dr. Karagis.
Yeah, I made a similar comment to Dr. Navasassian's comment under, I think, question number 4. And one other issue regarding the lead confounding would be to assess whether in that study the arsenic concentrations were actually correlated with lead. And I think we'd have to go back and look at that. But what I wanted to say was something regarding Dr. Pesa's comment on the masking. I and it may not pertain to the Wasserman study, but I did notice as I was going through the criteria and the ratings that some of the studies might not have articulated that the lab was masked to case control status or exposure level, or I guess it would be case control status. But because it wasn't actually explicit in the paper, they specified that. So it didn't necessarily mean that the lab that hadn't been masked, because frequently labs are masked and you just send samples. But because the paper hadn't said that, it came out in the evaluation. So again, I don't know if that pertains to Wasserman, but that's just something that I noticed as I was going through the articles.
Okay, thank you. Dr. Post and then Dr. Gribble.
I didn't really, respond to this question, but I just wanted to comment on Dr. Wyckoff's comment about the Wasserman study and the lead, because I did read that paper. I didn't interpret the way it was written in the paper. I didn't interpret them as saying it could have been explained by lead. I think they were trying to put their results that they found on the impact of arsenic. They did say they didn't account for lead. That's true. But when they said that the magnitude of the changes they were seeing was similar to what's seen with lead, they weren't saying that those changes in their study were possibly caused by lead. They did not say that. And I don't think that's what was intended when they did say that one of the uncertainties of their study was that lead wasn't, measured, but when they talked about the results, they didn't say it could have been explained by lead. The lead, I believe it in Maine was probably natural lead not from contamination as far as I know, because I know in New England they have that. And arsenic, lead in drinking water I meant to say arsenic if I said lead, sorry. The arsenic in the drinking water is from like natural geological formations. Lead in drinking water is almost always due to the corrosive qualities of the water and the plumbing and the distribution system, and from a private well, the plumbing within the home and the well. And I don't know if there's most of us are, I don't know if there's anyone on this panel who knows a lot about that. There's geologists and people like that. Like, is there information to suggest that water is more that when there's arsenic in the water, it's more corrosive and tends to release lead from the plumbing and piping in the home more than low arsenic? I don't think I think that was just something they said that they didn't account for, but I think it might, and I'm be making too much of that here for that study.
Yeah, fair point. Certainly because of lead and copper rule, drinking water is being assessed, and there should be data to know, if that's an issue in the study area.
Lead, the current lead and copper rule, you mean, right? Yeah, lead's measured in, well, yeah, that's true. Lead's monitored different than other contaminants. These are private wells too, so I know, unfortunately, I know like a lot about this it's a kind of complicated, but I think that it probably is known if lead's a problem, if lead's a problem in private wells in Maine, probably, or someone knows something about that.
Yeah, Dr. Gribble.
Thank you. Thank you. So I kind of hear two different points from Dr. Wyckoff and Dr. Post about the potential for unmeasured confounding and threats to internal validity of a study, and whether lead is really a threat for interpretation of the arsenic, or they were just contextualizing the magnitude of the arsenic effect by saying it's similar to what you might see with lead, which is debatably correlated or uncorrelated with arsenic exposure, and therefore potentially a confounder or not. But coming back to what Dr. Navasassian was saying, and this will be discussed further in a later charge question, something can be highly rigorous and highly relevant, but hard to plug into the meta-analysis framework that EPA adopted. And so a specific example of this, one of the studies that I was involved with, Bulk et al. 2022, in the main paper, the primary exposure comparison was per change in probability of the water exceeding some arsenic threshold, so 10 micrograms per liter arsenic. So it's a water-related variable, but it's not a quantity of arsenic in water. So it's hard to plug that directly into meta-analysis. They did in that paper, supplemental table 3, have an actual comparison across dose ranges of arsenic, so less than 5, 5 to 10, 10 plus. And so that supplemental table could potentially be in the meta-analysis. I didn't see that paper in the meta-analysis, so I flagged that as a maybe this would be a +1. But I could see how if you were just looking at the main papers tables and not getting into the supplements, you might see this and say, this is a really well-conducted, I'm flattering myself, this is a really well-conducted, rigorous study. It's very on topic, but the parameter estimates that are derived in this study are not amenable to inclusion in meta-analysis because they're on a different scale. It's hard to rescale them to be consistent. So I think this gets back to Dr. Wyckoff's point about like, how is this used in the risk assessment? There's the hazard identification stage, and then there's the dose response estimation stage. And a study could be high quality, but not make it that final step. And that doesn't mean it's a bad study. It's just that they couldn't grab the right data from it for what they needed.
Well, there is the opportunity to recommend they look at best study ever. Dr. Navasassian, you were going to speak.
Yes, and I just wanted to, I agree with Mark, with what Dr. Caraga said about the masking, that many studies don't have enough space in the journals, or, you know, it's such an obvious thing. And I noticed that when looking at some of the studies, I was like, oh, I knew this is a mask study, but the EPA cannot make that judgment if that was not included. So that's why some of the masking might look like downgraded in quality, while most likely many of them were, the masking was appropriate. And that makes me comment on what I wanted to say earlier about what Dr. Pesa said about the quality of the journals and the peer review process. You know, while that probably is something debatable, and I think it's kind of risky to go that route, because of course there are many journals and many review processes, but many of the articles are published in the top journals, in excellent journals, both medical journals, environmental health sciences journals. So I think overall, there is a strong peer review process supported by very rigorous journals. Might not be applied to all the literature, to all the journals, but that would be risky for us to say which are the journals that are good versus the ones that are not. So I thought that it would be very hard for us to make that call. So I just wanted to comment on that. Yeah.
Okay, thank you. Dr. Wyckoff, are you still up, or is this a new one?
Just a quick clarification. Yeah. No, I really appreciated this discussion and wanted to just highlight one aspect. First, yes, that I was making a comment about methods only, not about the actual impact of the study or anything in that. But what I liked about that discussion a lot is it showed the importance of some of these, you know, kind of identifying either on an outcome or exposure level basis what's important to the reliability or internal validity of that study. So, for example, Dr. Post talked a lot about, you know, she knows a lot about lead and its impact, et cetera. But in the protocol and in the assessment, in that outcome, there was no a priori identification of co-exposures that would be important. So from a methodological standpoint, I think it would have been good to say that up front and then assess all of the studies based on that, if that was determined to be important. I'm just using that as an example because we've been talking about that. So maybe that helps to kind of clarify my comment on this a priori outcome specific refinements as it relates to critical appraisal.
So Dr. States and then Dr. Barton.
Yes, just very quickly, I wanted to respond to Dr. Post's question about if arsenic containing waters would mobilize lead from pipes. And it's actually unlikely because you need acidic water to mobilize the lead, and generally arsenic is insoluble at acidic pH, and arsenic containing waters are generally either neutral or alkaline.
I was just going to say thanks. There's always a lot known about these things that people who do like human health risk assessment, human health stuff aren't familiar with. So I'm glad you knew about it. Thank you.
Okay, Dr. Barton.
So just as a general comment, and we haven't been talking about tiering of recommendations and so forth yet, but so this has been a really interesting discussion to me. I think, one of our challenges is going to be, we'd like EPA to bring this evaluation to a conclusion. And so being really clear about, well, there are improvements that could be made versus this is really a problem in the current analysis and needs to be fixed. That's going to be a real challenge for us to be clear about. And I think it's really appropriate in terms of the discussion that was just going on. There's no question that, I've been on several committees now that were evaluating issues relating to try to implement systematic review in environmental assessments, and like this issue of having a specific question, which there isn't a specific question. There's probably 10 or 100 questions, So anyway, so my point is we'll have to, work through this so that our recommendations are really clear about sort of helping them evolve the process for future assessments, for future redos versus things that critically need to be, addressed for this assessment.
Okay, thank you. Thank you for that. Is yours up again? The two of you? Okay. No worries. No worries. Everybody forgets to put it down periodically, especially me. I just wondered if I could indulge the panel a moment and ask Dr. Lee or someone from EPA just to comment on the issue of supplemental material submitted as part of a journal, and if they are able to assess that, and related to some of the other comments we've had here on the acquisition and evaluation of risk of bias of papers. Can you speak to that?
What's the question? Is on supplemental?
So the issue has come up that we know that sometimes journals, because of word count or page restrictions, do not allow authors to include as much detail as they'd like to on quality assurance, quality control, blinding, all those kinds of methodologic issues. And but they're often in an online supplement to the journal. And the question is, in the screening process that you go through, are you able to go to that next step and look at the online supplement? And Dr. Thayer is shaking her head yes. So can one of you just speak to that? Is it more than a yes?
Yes, as long as it's publicly available.
Okay. As long as it's publicly available, that is assessed.
Yeah,
okay.
It makes it through the title and
Yeah.
Okay.
Okay. So to repeat that for those online, if it goes through the title and abstract screening process and it goes to that next level, as long as it's published, even if it's published as an online supplement to the journal, that material is available for assessment and is assessed. So I think that's a good clarification because I wasn't sure of the answer to that myself. Thank you. Okay. Anything else from this one? Let's move forward then to question 2B, and let's hear from the lead discussant, Dr. Karagas.
Thank you. So of course my computer died just as I was about to start.
Take your time. No worries.
Okay. I lost my notes. That's okay, I have notes. I just wanna, in the spirit of what Dr. Barton said, I think there was agreement amongst the panel who reviewed the charge question 2B that the overall presentation of the results are clearly laid out and reasonably presented. And I think we've heard, and following up on some of Dr. Wyckoff's comments, that there are ways they could be more effectively organized and described so that we can follow the flow of results from the individual studies and data sets from one section to the other. So just the main point is that the committee felt that the results were well presented. And then secondarily, there are ways that it could be improved. And just to be transparent about how you get from one step to another, for example, I did notice that sometimes the studies in the text don't appear in the valuation tables, but it wasn't always clear. And some of those might have been some of those low confidence or uninformative studies. And then I did see that there were times where there was discordance between what was in the forest plot and then what was in the evaluation table. So probably not frequently, but I think that we want to be clear that these are the studies that were evaluated and these are the ones we put in the forest plots. There may be a selection process of studies that go into the forest plot, but sometimes it was the other way around where they were in the forest plot but not. So articulating why that, that process of what was included in which tables we think would be helpful. The other distinction that has come up many times already is that there are studies in more highly exposed populations and those at the lower dose range. And sometimes there was separation between those studies. These are the studies in the more highly exposed populations, and these are in the the exposure levels that are more common to the US, and keeping that distinction where it's possible would be helpful throughout the report. I think we might have brought up some of the nuances with regard to assigning study design, that cross-sectional studies need to be carefully described because it's not always clear that they're cross-sectional. And this will come up when we evaluate the specific outcomes. So we don't have to talk about it extensively here, but the question is, are they talking about prevalence rather than mortality or incidence? And that just needs to be clarified. And then this is a point brought up earlier too, that urinary arsenic, it's important to say whether the study actually speciated arsenic and excluded arsenobutane, which primarily comes from seafood. And if they did not do so, to specify whether the study was conducted in non-seafood eating populations. So while we're pleased that the urinary arsenic studies are included, just making that distinction is important. Studies of pregnancy and early childhood are covered under a separate section, which is appropriate, but why do they not always appear in the forest plots? It kind of circles back to that other issue. Dr. Wyckoff brought up the issue of effect modification and that to better describe and explain the process for identifying those studies. The description is within the description of the studies that came up through the search criteria, and then they're enhanced with a targeted search. But I think understanding, and Dr. Wyckoff can elaborate on this, that what was the approach taken, and then how were the data incorporated into the assessment and the synthesis could be clearer. with regard to life stage, we've got the susceptible windows of exposures that are covered as risk modifiers, but life stages can also be classified with the respect to the timing of the occurrence of the outcome. So the outcome occurred during a certain life stage, like gestational hypertension or diabetes or childhood blood pressure. And I think the distinction between those two aspects of life stage could be made clearer in the document. And there are a number of other technical issues, making sure, for example, in the forest plots, are we talking about incidence or mortality? And maybe some groupings and making sure all the units are there, etc. We can give you all of those comments. And I think a point Dr. Anna Navas made earlier is being able to put the estimates on using the same units and scale. And I think there were some points made. Dr. Pesa brought up, which has been brought up earlier, about the mechanisms are superficially addressed. And moreover, they may reflect biomarkers of disease rather than the underlying causes or disease initiation process and progression. And also had some other comments. And I had integrated my notes, but I'm not able to get them. For other of Dr. Wyckoff's comments, some of them have been discussed. For example, formal consideration of the impact of systemic and residual bias and dose response, and formal assessment of biologic plausibility mode of action relative to dose response in the association studies. And I'll let them elaborate. I think with respect to risk of bias, there were some suggestions of using tools like DAGs and e-values with the references provided. And then I can just stop there and let the others speak.
Okay. Very well done. Hopefully your computer comes back to life here.
No, it's here.
Okay.
This is the notes.
Okay. Let's hear from Dr. Barchowski.
I really don't have anything to add other than I thought things were very well done.
Okay. Dr. Pesa.
Yes, I agree. Things were well done. There were just a few typos. For a non-epidemiologist, when you see an N at the top of a column, you expect to see some numbers below it, but I may have misread some of those. I think there are a few typos. I try to point out where they are, but they're relatively minor.
Right. Yeah, I think a number of us have identified typos along the way, and it's helpful, I think, to flag those. And it's a different discussion, but good to have those corrected in the final document. Dr. States.
I have nothing to add.
Okay.
Excellent job summarizing.
All right. Dr. Wyckoff.
Thanks. Yes. So I just really want to echo the kudos to synthesizing a lot of information. This is really hard, and I like the balance of narrative, figures, external programs, et cetera. I think that was really helpful. It was also a very good summary of the comments. The only thing that I think I'll build on just a little bit is, not being an epidemiologist, I did struggle a little bit with making sure that I was able to follow when we were talking about covariates, confounding, and risk modifiers. And this really struck me when I was reading the synthesis, and there's a whole section in each outcome for risk modifiers. But the risk of bias question 2 or 3 specifically says, do these studies address all the modifiers? And so I don't know if when you're talking about the risk modifiers in the synthesis, if you're referring to something different, or if these would be used differently. And I found myself thinking, well, if they're important modifiers to that outcome, how come they weren't considered in the risk of bias? So in terms, thinking about Dr. Barton's comment, the one thing I would say for this assessment that would be high priority is just clarifying, confounding covariates, risk modifiers in risk of bias, and then what you're also meaning in the synthesis for the more susceptible populations. I think that would be very helpful.
Okay. Okay, thank you. Are there comments on question 2B from other panel members? Or any clarifying questions?
Maybe I'll just briefly mention that it's covariate is a very broad term that is not very specific. It's helpful because sometimes we don't know if some covariates are true confounders or not. So it's kind of nice to use a term that is not kind of assigning that strong label. So we often do that a lot in epidemiological studies, to use the term covariate, but it doesn't really mean much. So I think in terms of defining categories of covariates, I think it's helpful to try to say, yeah, possible or relevant confounders that should be accounted for. And I agree. I think Margaret mentioned about the using DAX or some strategies, which might be difficult to do, but ideally that would be good. But yeah, confounders and effect modifiers, that sounds like reasonable. Can we at least have those clear sections that cover those? Yeah.
Yeah, good point. Others? Okay. Let me just confer with the DFO here a second. Yes, why don't we take a short break before we, and that way we'll handle question 3A, B, and C together as a group rather than splitting them apart. So we'll take a 10-minute break right now, and it's only 2:32, so we'll come back at, we'll say, quarter to the hour, so 2:45 Eastern time. If
You should see this. It's a cat on the ice.
No, I need to focus, so I can't see it.
okay, we're reconvening.
Wonderful. It's should I go ahead? It's question 3A, yeah? Is that right?
Yeah, so let's just give a second for folks to sit down here in the room. Yes.
But maybe I can start by saying that's the moment of the break is when I am the most jealous that I am by myself here and all of you can chat and it's really, I really miss not being able to see everybody in person. It's so far it's been such a great discussion that I really miss. Unfortunately, I have there were some family health issues going on, and that's the reason why I decided to stay. And my husband had to travel urgently last night to Germany, so I knew that it was very risky for me. Yeah, unfortunately, his mother is very sick.
Well, we wish you were here, but we'll do everything to include you as much as possible and hope for another time when we can be in the same room with you.
Absolutely. And actually, and I want to congratulate the organizers of the meeting because the hybrid mode is working phenomenal, which most of the time it doesn't. So real congratulations. Yes, fantastic. The way the cameras look at everybody that is speaking each time, it really makes me feel that I am part there with all of you. It's really amazing. The technology has been great.
Thank you for saying that. And remember, there's people behind that technology and they're back in the corner doing a great job. So I'm glad you gave the opportunity for us to highlight them, and thank you. So yeah, please go ahead. We're starting the discussion of question 3, and we'll start with 3A, and obviously you're up first.
Very good. And so I don't know if people want to see question 3A as we were showing it earlier. Very good.
Yep.
And basically, this is there is a first at the beginning of question 3. There is like an overall introduction for all of us to do the same for each of the different outcomes, so that to look at the hazard identification process for the protocol, if the evidence has been synthesized appropriately, and describing the strengths and limitations, and commenting on the weight of evidence decisions, if it's described and appropriate, and the susceptible subpopulation have been included given the available data. And then each subsection is about a different topic. So the first one is about cardiovascular effects in humans, and the report in the IRIS process concluded available evidence demonstrate that that's happening. And the conclusion is based on the human evidence, which range from less than 10 up to quite high levels. And then the outcomes are ischemic heart disease and hypertension, as well as other cardiovascular disease endpoints of atherosclerosis and repolarization abnormalities. So my comments are that yes, the evidence for cardiovascular disease has been adequately synthesized. The effort is quite impressive, very comprehensive and detailed. It allows overall to obtain a full picture, including both the clinical and subclinical outcomes. I think this is important because it really allows us to see the full continuing, and again, to assess the different lines of evidence, again, the different ways of assessing exposure and the different outcomes, allows to have that full picture that all the outcomes is kind of consistent in the same direction, despite different limitations that might be affecting the different types of outcomes or studies. In that regard, I would like to make an echo point to the comment that Dr. Barczewski made earlier related to the fact that the experimental evidence in this area could be considered, is very relevant, and it could be an additional element of strength for this effort to include it also, because then it would also address, of course, the experimental evidence has other weaknesses, but it has other strengths that the epidemiological studies do not have. And that triangulation of different lines of evidence with different strengths and weaknesses can be very relevant for this hazard identification effort. So, but going back to the charge for this particular question, yes, I felt that it was well described, how the studies were identified, evaluated, considered. And then one of the key issues that we discussed already earlier is what happens with the studies that were identified by 2019 versus the additional studies identified by 2022. And I felt, and given the comment also made earlier, that this is a process that we cannot make it too infinitely complicated, I think it was appropriate not to include the additional studies for the beyond 2019 for the hazard identification, but just to include them for the dose response meta-analysis. I felt that was okay, unless for a particular outcome, this could be helpful. But for so I felt that was okay. Then I have some specific comments. One of them is related to figure 3.3 on page 35. This is a wonderful figure. I really like it. I felt that I was missing the studies for coronary heart disease or ischemic heart disease. I think most of the time they include the term ischemic heart disease. I think it's better to unify because those two terms are kind of similar. But that I didn't see that outcome listed. In that figure 3.3, we can see mortality, atherosclerosis, hypertension, electrocardiogram abnormalities, etc., but not the ischemic heart disease. I suppose they are within atherosclerosis, but that term is more general. It can include peripheral arterial disease, carotid artery intima media thickness. So that it would be nice to have that clear. And again, I think it's a little bit what the comment that Dr. Caragas had earlier, that sometimes it's not always consistent what's included in a table, in the text, or things like that, which is, of course, very hard to do given the breadth and the magnitude of the effort. But I think it will be helpful for this particular figure, especially given how important this ischemic heart disease outcome is, and that it's included in the dose response later on. Then in the other figures, which are the figures for each of the different outcomes. So let me see. It's starting at, I think it's in page 313, they start, figure 3.5. Those figures are super helpful in general. I really like them, that they include the outcomes specifically, they include the comparison set, the exposure group, the total sample categories, so that we know what are the different categories, and then the sample sizes. So that's really helpful. I felt they included a very broad axis for all of them, which makes it then a little bit hard to see for some figures. So I felt that they could have specific axes for x-axis for each figure, that I'd be fine with that. And then it's not clear to me how they were organized, because it didn't seem to be by year of publication or alphabetical author, nor comparison or levels. It didn't seem to be either. So I was not sure. Having a systematic way of ordering them, the studies probably would help. But these are, again, tier 3 comments. Let me see what else. And the same for the comments. I think the cross-sectional and ecological studies, sometimes they can be considered of less value in general, but I feel, again, it provides the breadth of the evidence. And again, each type of study is going to have a different weaknesses and strength. So by looking at them all comprehensively, I think it's really helped us to make an overall assessment about the hazard. And the natural experiments in particular, I believe, are very helpful in that regard, because it's a unique opportunity to see what's happening when you change exposure. And cardiovascular disease is an outcome that can be expected to change faster than other outcomes, given what we know for cardiovascular disease. When people quit smoking or when you change your pollution levels, we know that the benefit from cardiovascular or secondhand smoke policies, smoke-free policies, we know that you can see the benefit for cardiovascular outcome quite quickly. So the fact that we can include, even this is maybe premature, there are not so many studies in natural experiments, but for the future, I think and whatever it's available, I thought that was really good. There were some small typos or things that didn't make much sense. For instance, I wrote on page 318, it says coronary atherosclerosis is typically assessed using ultrasound to measure CIMT, and I felt that was not correct because this is carotid intima media thickness. Coronary atherosclerosis in the coronary arteries is really hard to see with ultrasound. You need a cardiac CT normally, so I think it's good to fix those typos or things that do not make much sense clinically, just to be correct. But so whatever I saw, I wrote it down. Then for the hypertension figure, I felt that having there the part of the arsenic metabolism is confusing, because that's very different. The arsenic methylation profiles in urine or anywhere else, but it's very different from arsenic exposure. It means something else. It's a different interpretation. So to include that together in that figure 3.13a for other hypertension outcomes, so this is a study, Lee et al. I would remove that for simplicity. And again, it's kind of mixing apples and oranges. Arsenic methylation is one thing. We should not mix that with exposure or trying to identify the hazard of arsenic exposure. So that I think it's important to fix. But in general, the conclusions are robust based on a large body of evidence. There are things to fix to make sure everything is appropriately described, but it's an excellent job. And the summary table at the end, I really like it. I felt it was very clear, very synthetic, and helpful. Then the reviewers had, Dr. Barczewski, I think, was in agreement that the weight of evidence decision is appropriately described. Dr. Griebel also, and that the susceptible subpopulations have been included. And Dr. Carol Wood had no additional comments for cardiovascular disease. And I saw Danielle Wyckoff mention in the Excel file that we got with additional reviewers, but I didn't see the comments. So please, Danielle, if you have additional comments, please feel free to add them. And I think that's all from my side.
Okay, thank you very much. So let me turn to the working group members here under this one. So next would be Dr. Barczewski.
As Anna mentioned, I really didn't have that much to add overall. I thought it was very well done and all was very well justified. I'll just clarify a little bit what I said in 2A and what Anna was referring to with the suggestion of possibly doing mechanistic studies, mode of action studies with cardiovascular. I know we're not tiering the recommendations right now, but I just want to emphasize that it's a suggestion to make things stronger. It's not a request to do this. And I think that for cardiovascular, it was the highest priority non-cancer disease in the NRC 2013. It seems to be a driver of the RFD. And so a limited amount of resources could be devoted to making things stronger.
Okay, thank you. Dr. Gribble.
Thank you. I agree with the summary provided by Dr. Navasassian that the available data have been clearly and appropriately synthesized. I also want to just highlight one of the charge question elements was about sensitive subpopulations. And I thought that the narrative text especially did a nice job of considering susceptibility factors, for example, effect modification by sex for QT prolongation in ischemic heart disease, and effect modification by methylation capacity for atherosclerosis. I thought that was nicely handled.
Okay, thank you. Dr. Wyckoff.
Sure, thank you for those, for the summary. The comments that I have are really applicable to all of these sub-questions because they really relate to the methods of how this information is being brought together to make a hazard conclusion and develop these categories. And kind of two main comments. One really relates to just kind of force-fitting systematic review, and the other is just around the term cause. I think, just looking in the IRIS database, there are 5 slope factors, I think, including arsenic, that are based on epidemiological data. The rest are all animal data. And so I think we should just need to keep in mind that, the practice has really been, when we're using these categories, hasn't been for the application to epi data. And this is all epi data now. So I would just encourage in the future, this is probably a future comment, that, the term cause bears weight and it also has a specific meaning. So it would be helpful to clarify, if those are causal relationships, and I think there is some indication to that in the assessment, but I think that the terms are used interchangeably. And then more specifically, I think that if it is about establishing causal relationships, that the integration of the information, even within a stream, needs to be around causal criteria. As part of that, that definitely gives you the opportunity to bring in experiment and biological plausibility, the things that we've been talking about. So it might just require reframing that a little bit. And that brings me to my second point, that I just would really encourage the program not to get stuck with some of the systematic review methods as you're applying them to risk assessment. While GRADE is a great tool, it doesn't do everything you need for risk assessment. So I would really encourage you to still use a structured and clear method. But if you need to adapt those methods further for use in risk assessment, I would very much encourage that, particularly as it relates to establishing causality categories for hazard.
Okay, Dr. Wood.
I don't have anything else to add on the cardiovascular disease presentation.
Okay, I was sort of chuckling, Dr. Wyckoff, you saw me, just because, it seems the agency's been beaten up so much about not adhering to systematic review and establishing a formal protocol and following their protocol and all that. And you're saying it's not the end all be all, and they should go beyond that. And I really get that completely. But if I were sitting in their shoes, I'd be, oh my God.
Yeah, no, I get that. I mean, I'm a practitioner myself, and I think you have to go through it to actually experience this. But I think really what it has brought is objectivity and transparency, but there's a lot of really good things. But so I wouldn't say stop using it by any means.
Yeah, fair enough. Okay, others on the panel who want to comment on 3A? Okay, and your mic is still on, Dr. Wyckoff. So we'll move to 3B then. Oops, sorry. I missed that. I apologize.
No, that's fine. I want to make one quick comment. I mean, To me, this is huge. Arsenic for years has been arguments over cancer and skin effects, etc. And getting people to focus in on the things that would really matter to the American public, like cardiovascular effects, not that the others don't matter, they do, but I think this is huge. So I think it's really important that we're as clear as possible about, this endpoint.
This is a a very important comment, and I want to maybe mention that like 6 months ago, the American Heart Association released a scientific statement signed by the president of the American Heart Association that indicates that arsenic is a cardiovascular disease risk factor. So probably you may want to mention that, utilize that also. Because, yeah.
Yeah, thank you for that. Yes, go ahead, Dr. Thades.
So we've heard that ambient levels, the background levels are sufficient to cause disease. Cardiovascular disease is the #1 killer in this country. And I just posed the question, is there a link?
Okay, we'll let that float in the ether out there, huh? We'll have an opportunity to come back to that one. It is meant to be provocative, he says off mic. Nothing is off the record. Okay, very good. Well, I think we're ready to go to question 3B. And this time I'm going to, of course, start with lead discussant, but then I'm going to go in reverse alphabetical order because I'm tired of alphabetical order. And my name is at the end of the alphabet. Okay, go ahead, Dr. Navasisian.
Very good. Okay, great. So now we have to do the same exercise for the diabetes evidence. And I felt the quality and organization was kind of similar. So I felt it was appropriate. Although I felt for the diabetes studies, for the arsenic, I felt all the key studies were included. I really didn't see anything missing. But for the diabetes studies, I thought that some studies were missing. For instance, there is a study that I am very familiar because I was involved. It's a stronger study on arsenic and diabetes incidence, Kuo et al., published in Diabetes Care, the journal. And that study is mentioned in the text, but it's not included in the tables. In figure 324, I would have expected that study to be included. That study is actually null, didn't find an association. But to me, that doesn't matter. We need to be inclusive of all the studies. So why was this study not included here while other stronger studies were included? So that was not clear to me. For instance, the study Grau-Perez et al. Is the same population except is younger because it's what is called the family cohort, which are younger people. So that study is included, but the original cohort, which were the older participants, originally in the SOHA study, were not included. So for me, it will be important to make clear why, and I don't see any rationale. So I think it's important to include all studies when they support the evidence, when they do not, because hopefully when we see everything in aggregate, is where we can see where the trend and the direction of the association is. And I think it's also because of this comment that has been mentioned before of the cherry picking. I think the comment that Dr. Paolo Bofetta had was kind of similar for why would you include one study for lung cancer but not for bladder cancer? So here is kind of the same. Why would you include the stronger study for cardiovascular disease but not for incident diabetes? That's not clear to me. So I think it's really important to be inclusive, transparent. And I think this is the comment from Danielle Wilkoff also is that we cannot be cherry picking. We need to have clear, consistent criteria that are applied consistently so that it cannot be said that there is some cherry picking going on. So, but overall, the evidence seems robust with some inconsistencies for type 2 diabetes. I felt that for type 1 diabetes, there is not really enough evidence. It's particularly difficult to study type 1 diabetes. The evidence, if anything, is primarily for arsenic metabolism and actually for exposure. There is not, and it's only one study. So I would not try to make a case for type 1 diabetes, also because the mechanistic evidence here, which is similar to the comment made for cardiovascular disease, given the amount of experimental data for type 2 diabetes, mechanistic, experimental evidence, I think it will be appropriate, particularly for this outcome, to also dedicate some small effort to review that experimental evidence. And that's mostly for type 2 diabetes also. So I think the type 1 diabetes, I would not mention too much about it. And I think that's the comment from Dr. Barczewski. He also mentioned about the experimental evidence. And I am going to stop summarizing what the other reviewers had, because I think it's better for them to do it. I thought at the beginning that the main reviewer was supposed to summarize everything, but I let them speak. Thank you.
Just a question for you. Did you say Guo or call?
Kuo is Kuo. Kuo. I am not sure what the right pronunciation. Kuo.
Okay. Thank you.
Kuo.
Yes. Thank you.
2015. And I can provide the exact reference if needed.
Yeah.
It's published in Diabetes Care.
Great. Okay. I just want to make sure I record that properly. Okay. So next we'll hear from Dr. Wood.
Thank you for the summary. And I agree. My biggest concern was that the different types of diabetes were not delineated clearly, and that the emphasis should be, and the synthesis should be on the type 2 diabetes, and maybe some more gestational, because the evidence seemed pretty strong for gestational diabetes as well. And that was not really brought out strongly. But it's not until like way into chapter 4 that you even know that we're focusing on type 2 diabetes. So I think that would be much clearer in the synthesis section in chapter 3, and then in chapter 4 as well, to just focus on that instead of the blanket phrase of just diabetes, to be specific, and the data that were used for that modeling. So that's what I had on that.
Okay. Okay, Dr. Wyckoff.
Nothing more to add from the general comments.
Thank you. Dr. Gribble.
Thank you. I also just wanted to, in response to the charge question, consideration of sensitive subpopulations, note that the narrative text did talk about various susceptibility factors, I thought, in a reasonable way. For example, arsenic 3-methyltransferase genotype and vitamin B intake for HOMA2IR, which is a measure of insulin response, and then folate intake as a modifier of arsenic metabolism associations with type 1 diabetes. That's a little bit less clear because arsenic metabolism phenotypes are distinct from arsenic exposure levels. And also type 1 diabetes as an outcome is biologically different from type 2 diabetes. So if there's a de-emphasizing of type 1 diabetes in the revision, you might want to think about how you talk about the arsenic metabolism relationship to type 1 diabetes. But in general, I thought that they did a nice job of considering sensitive subpopulation considerations in their narration of the hazard identification section.
Okay, thank you. Dr. Barczewski.
I don't have anything to add.
Okay. How about the rest of the panel members? Anything on diabetes?
Maybe something I would like to mention related to the public comments.
Sure,
that I think might be important also, because this could be an important source of criticism. which is related to and applies not only to diabetes, but maybe particularly relevant for diabetes, is the issue of a correction for urinary creatinine when you use urinary arsenic as a biomarker. So that's it's a complicated fact. We know we need to correct for urine dilution because that's a huge measurement error problem. The question is, which is the best strategy? Is adjustment for urinary creatinine or correction for urinary creatinine versus correction using specific gravity? One of the problems with specific gravity is that it itself has a lot of measurement error because even though it's a quantitative measure, the methods are not sensitive enough. And often they only have like one unit, like you are quantifying 10 possible values, basically. So it's really semi-quantitative. And so that's a problem in the sense that you don't account as well. But I recognize that the urinary creatinine could induce some potential bias. And so that I think needs to be acknowledged, discussed, but at the same time, that's why the studies that use water arsenic are useful because they are not affected by that. And how much urinary creatinine you have is not going to change the water arsenic or other problems or reverse causality. Your early diabetes cannot change the water arsenic level. So that's why, again, this issue of balancing the different designs. And there is a study that we did to validate or to assess what is a good way to correct for urine dilution problems. We looking at water arsenic as a marker or blood arsenic, which is not affected by dilution and volume issues. And we found that actually correcting for urinary creatinine is one of the best strategies. It's able to do a better job than specific gravity. I am going to put this in the chat, that reference, in case it can be useful, because that can help to address some of the comments from the public comments, which I felt were legitimate. Yeah. And I believe there is a little bit about this because some of the cross-sectional NHANES studies are summarized and they dealt with that issue also and that's included in the IRIS report, which is, I think, it's a good thing to do, to be transparent about these complex issues. Sorry for adding this at the last minute, but I remember that I thought this was important when I listened to the public comments.
Yeah, no, I think that's extremely useful. Just to the follow-up question, does the issue of collection at first morning void versus other times weigh into this at all?
I don't think so, because even the first morning void can be affected by volume, and it's very hard to do. There are so few studies that have done first urine void. It's practically impossible in a big, large epidemiological study to do it.
Yeah, I set out with that as a goal and wasn't able to achieve it in a study I finished. So I'm glad to hear you say that. Okay. Yeah, go ahead, Dr. White, Gribble, sorry.
Just to build on Dr. Navasassian's point, there was a previous comment about whether controlling or not controlling for urine creatinine would make some categories of studies invalid or ineligible or failing to meet quality assurance, or however you want to word it. Often in studies, they'll present both a creatinine adjusted and a creatinine unadjusted result. And in quite a lot of the studies, the findings are similar. Or if there's a quantitative change, it's that the measure that doesn't control for the urine creatinine is slightly more attenuated because we think of the urine dilution issue. So it's not a panacea. All of the approaches have some limitations, but I think that if EPA, for the studies that are included in the final dose response especially, can note if the original papers did a comparison and had consistent results, that might address some of the concerns about study validity. Is actually the results are very robust to this. And we looked at it a couple of different ways in the primary literature and the results were consistent, because I think excluding studies because they did or didn't control for it, if it didn't really change the conclusions, is throwing the baby out with the bathwater.
Yeah, that's a good point. And I'm glad that we're all coming back to and reflecting on the public comments, because that certainly is a super important part of the process. And I just like the fact that I can see that reflected in our discussions. Other comments at this point? This is 3B. Diabetes. Okay, so let's move on then to 3C, and we get to hear from Dr. Chen.
All right, 3C is about a pregnancy and both outcomes. So we have me and Dr. Carragus, Dr. Wyckoff, and Dr. Wood actually on the group, and we the majority the opinion is EPA has clearly and appropriately reviewed the inorganic arsenic exposure and pregnancy and both outcome following the protocol and identifying relevant studies up to 2022. So EPA examined the quality of FBE studies by assessment, exposure, and outcome assessment, bias, and interpretation. Overall, the weight of evidence is justified and interpretation is generally reasonable. However, we also found a few points that may be used to improve the work. One is the high dose and versus low dose, because the arsenic exposure spans from really low to very high in different countries, in different regions. So for some outcomes like neonatal death, or fetal loss or stillbirths, maybe high dose that be more relevant. And however, there are more studies come from US that looking at some of the pregnancy and both outcomes. And we think that it's possible to make a little bit distinction between high exposed population and other low dose exposed population. And it's possible to let EPA think a little bit more about whether that the study can be summarized in a way by median exposure levels. For example, it's over 200 or it's below like 150 to 199, something like that. And then, 100 to 149 or below 100, it can even make a little more specialized like categories like less than 50 or less than 10, something like that, to just like a little bit more work to do, but it can really tell the dose response, looking at different doses a little better in a way to show the association. And also, Dr. Carragus mentioned that there are some studies excluded, not included in the simple table that we can access to. It's in the HOC, but it takes some time to get to the review. And there is comment about causal pathways. So the pregnancy both outcomes sometimes, especially birth weight, can be affected by multiple factors like the maternal BMI, the glucose levels, or gestational age. So these could be on the causal pathway to birth weight, and whether we should adjust for those. It's a question. Most likely, we do not really adjust for the intermediate variable on the causal pathway in the assessment of exposure and an outcome, and that is something we want to mention. There is discussion of cross-sectional study versus prospective study. A lot of pregnancy in both cohorts, if they actually had exposure assessment before birth, let's say first trimester or second trimester, most people would consider that as a prospective study instead of a cross-sectional study. So that is, for the distinction between cross-sectional and prospective study for the pregnancy cohort. And also, there are some studies involved in the, for example, in the gestational age literature review for the synthesis of the evidence, but not the birth weight. There is a Howe 2020 paper that's as an example. So we want to understand a little more why some of the study was involved in one outcome, but not the other for the evaluation figures and forest plots. On the exposure of inorganic arsenic, so urinary arsenic has biomarkers, and it can be from inorganic arsenic or from organic arsenic from seafood consumption, and whether we should adjust for that as number 10 or actually try to adjust for seafood consumption or speciation of these arsenic species would be interesting for us to really understand what's really the inorganic arsenic exposure. And for the drinking water inorganic arsenic levels, we hope to really see EPA provide some information about correlation between drinking water arsenic levels and maternal urinary arsenic concentrations, because there is a volume expansion during pregnancy that we relate to potential concentrations of urinary levels of environmental chemicals. If the inorganic arsenic levels was measured in the blood, so that half-life is supposed to be very short, and we hope to understand how the variation of this inorganic arsenic in blood samples during pregnancy, what's the intercorrelation correlation coefficient? That is something it's not really showing there. So in terms of try to interpret the findings from reports with arsenic measured in blood samples. On the environmental recent, there is certainly EPA had a cutoff by 2022, but there are some more studies recently about a mixture exposure that including arsenic as one of the metals, but could be some others. So there are several studies identified that could be used by EPA as a way to understand whether those arsenic is in the mixture setting or what is the association with outcomes compared with just like arsenic as a single chemical to study. That is just like for EPA to consider. On the outcome side, the report talked about just the pregnancy outcomes, but not just in the diabetes and the hypertension. We talked about diabetes as one, as a 3B question, whether just in the diabetes can be put in that diabetes or can be put in pregnancy outcomes. That's another question. The same thing is just in the hypertension, because hypertension was cardiovascular, but also pregnancy-related outcomes. So if EPA would not putting these two into the consideration, the title, section title can be changed to fetal, neonatal, and infant outcomes instead of pregnancy and both outcomes. So also some of the outcome definition, because so many pregnancy outcomes kind of like you need definition for preterm birth, for fetal growth, and for head circumference, for like some of these outcomes and fetal loss. So the definition, not only actually the condition, but also who report this condition, who measure this condition, and the timing of the event is also important. For example, fetal growth. Are you talking about first trimester to both, or are you talking about second trimester to both, which is different? So these could be considered a little more carefully. On the fetal loss and infant death, so we actually think EPA said there is a general consistency, and that is acceptable. However, there are some studies not found associations. So I think we think probably EPA could be a little more specific, saying there are some studies and they not found association. And there is one area, actually, the page 397, talk about direct toxic mechanisms regarding to infant deaths, but EPA is very generic, talking about what are the possibilities that as mechanism leading to infant deaths. Diarrhea and a lower respiratory tract infection was mentioned, but it's very brief. So I think, but to understand these some of these outcomes, it may be important for EPA to write a little more on the potential mechanisms on the infant deaths, especially those outcomes. On the birth weight, there actually in 2023, there is a paper, certainly EPA did not look at that, that is reasonable, but we just want to mention that ECHO Consortium recently published a paper did not find any association between area level arsenic exposure, which is in drinking water, and both weight. This is a large study, US several cohorts. It's a pooled study. So this just like can be put into the consideration to summarize the outcome with both weight as the way to understand, so whether the both weight is really the outcome, sensitive outcome affected by the arsenic exposure at US levels, not the international like high exposure levels. On the on prematurity, one panel members thought the prematurity section should be placed before both weight because it's more related to both weight and on the cause pathway and also the primary cause of infant mortality. The other one is sort of like both effects, but EPA we did not review the both effects part as well. So that there is also discussion about postnatal growth. So head circumference in both lengths, the growth are sort of like maybe a little bit different, and it's possible to differentiate that into two different smaller sections instead of lump them together. Finally, there is comments about potential risk modifiers. For example, pre-pregnancy BMI, or basically obesity status, or undernutrition. Or actually, I was thinking about a racial ethnicity as like potential socioeconomic status as effective modifiers of arsenic exposure that can be potentially relevant in the US. So I'll stop here and see if others, Dr. Karagas or Wyckoff and Dr. Wood would have anything to add.
Can I just ask on the recent study on birth weight US levels that you mentioned, what's the author on that?
The ECHO study is by Lewis, JV et al. So this is Environmental Research 2023-236 issue, and there is actually, it's in the comments, yeah, Lewis JV, sorry, et al.
Great, thank you. Just to make sure we get that down. Okay, so next let's hear from Dr. Wood.
So I have to admit, the first time I read this and read that arsenic causes birth outcomes, I was a little amused. Then figured you meant adverse birth outcomes. But in looking at maybe we figured out how that happened. Figure 331, there's other evidence that's as strong, and we've already had the discussion of using different measures of arsenic, whether it's drinking water or blood or urine, but there is other supporting evidence. And the one study that is used for modeling later or for a point of departure, the Kyle study almost looks like an outlier when you compare it to the rest of the studies on the graphs. So I would like a stronger, I think, presentation of the positive studies and how those relate, because there's an awful lot of just negative or null studies here too. So I think it could be a stronger presentation for, especially the Wang study. I think shows some dose response, shows so I think birth weight is just the strongest endpoint, but it's not real clear why you narrow that down to just the one study at the end, except that as we had the discussion earlier, for lack of conversion factors for doing the benchmark modeling.
Okay, thank you. Dr. Wyckoff.
Nothing to add.
Okay. Dr. Karagas.
Just a couple things. The Lewis study was based on arsenic violations in public water systems. So while I think it can be mentioned, it's good that it was brought up, but I don't know if it will end up being one of the informative studies. I think that's for the EPA to look at.
So basically, it's stratifying on 10. Are you above it? Are you below it? And any,
It's based on the number of violations.
number of
Yeah,
violations. Okay.
there's some metric based on the number of violations. Yeah. Thank
Yes,
you, Dr.
yes,
Chen.
yes.
Yeah, and I thought Dr. Chen's summary was excellent. And just to clarify, I had made the point about separating head circumference from length and other growth measures, not as separate sections, but when you're talking about fetal growth in the summary, to separate the summary of the different outcomes, but I don't think they necessarily need to become separate sections. I also think it's was really valuable to have this section in the IRIS report. And the point about urinary arsenic, there are a couple points there. The point was that there was a comment made that using urinary arsenic might result in increased variability. For studies that did not speciate and exclude arsenobutane, and in populations eating seafood high in inorganic arsenic or other forms that produce the metabolites of inorganic arsenic, that may be the case. But otherwise, I think it's important to make the point that when you use the biomarker appropriately, the reason that epidemiologists do that is because it reduces misclassification. Because water at low levels of exposure, if you just use drinking water level, could introduce a certain amount of misclassification, potentially non-differential misclassification. And the motivation to use a biomarker is actually to reduce that misclassification at the lower end of the dose response curve. So I just wanted to make that point because it's a more general point regarding the assessment. Thank you.
Very good. Thank you. Yes, so I got several. Yeah, I think Dr. Chen is raising his hand more vigorously than Dr.
I just
Goebbels
want
is raising his card.
I just want to echo so Dr. Wood's comment about Kyle study in that figure. So because I wrote that as a specific comment, not talked about. There are some typos and some other specific comments I did not really speak. But yes, I do also notice that Kyle study is outlier in that figure, and that EPA considered that as one of the critical study for birth weight. And this is something I think certainly probably more thoughts should be getting to this whether this study is really the best study really as the dose response for the birth weight outcome. I just want to comment. Thanks.
Dr. Grubel.
This is an addendum and self-correction to something I said earlier. I had said that total arsenic is stable across pregnancy. It's the species composition that changes. I just found two studies to the contrary. There's Oppenheim 2003 and Gao GAO 2019, where the arsenic changed across pregnancy. So I think it might, like Dr. Karakas was saying, need to consider species and control for arsenobutane to be confident in those studies. But I do think that making use of the substantial biomarker-based pregnancy evidence is useful.
Matt, sorry, Dr. Gribel, the Oppenheim study, I believe there was an intervention in the middle. And if I recall those studies correctly, that why they look before and after, and there was a change in exposure. And they were able to show that the exposure changed, but that the methylation patterns didn't change. I think, I might not be recalling this correctly, but I remember reading those studies many years ago. I think you said 2003. I remember those studies.
It might be a different study.
Okay. Sorry. Yeah, maybe I don't remember well. Sorry for this.
So if you look at it in like PubMed or something, it should flag if it had a follow-up or correction or addendum or a retraction or anything like that. Yeah. Okay. Right. Comments on 3C from other panel members or circling back to reviewers? And online, any of our folks online, Isaac or others?
No.
Okay. Just wanted to make sure I hadn't neglected those of you who aren't in the room. Okay. So we have accomplished a lot today. And I think we're at a point where we can, it's not on the agenda, but I had thought it would be good to have sort of a circle back and a recap at the end of each day before we adjourn. And especially since we are ahead of schedule, we have the opportunity to do that. One of the things that came up this morning was a question from the panel during the EPA remarks. And we asked for a follow-up regarding some information on the Wasserman study. And Dr. Janice Lee is and her team is prepared to respond to that inquiry. So Dr. Lee, if you want to come up or send the appropriate person, if not you.
Yeah, makes sense.
Okay, please introduce yourself. And while you're doing that, thank you for following up on this and being so responsive. We appreciate it very much.
Hi, yeah, this is Rachel Schaefer. I'm an epidemiologist with the IRIS program. So I think the question was whether the Wasserman study excluded individuals with intellectual disability. Was that the question? There was concern about that. We went back to the study to clarify, and that did happen, but it only ended up excluding 2 individuals. So we're not really concerned with any sensitivity or other bias issues there.
Dr. Pessa, you want to respond at all or ask anything following?
Well, as I've heard already say, I'm not an epidemiologist, so that does still concern me about other exclusions that may or may not have occurred based on this. I also am wondering where the cutoff in IQ was before they considered it. That would have had to have been reported, I would imagine, but again, it raises quite a bit of concern on my part that were the levels very high in these kids.
Mm-hmm. So I think we could take a look at that paper tonight or whenever and try and determine what the cutoffs were that they used and all those sorts of things. Satisfy that, and we could bring that back for discussion subsequently if we wish to do so. All right. Thank you, Dr. Schaefer, for following up. I appreciate it very much.
Dr. Thorne?
Yes.
Given that we're ahead of schedule, would you consider us moving on to 3D today, or do you want to adjourn early, or what is your preference?
Sure. Let's see, where are we here? Oh, yes, we're well ahead of schedule. Let's see, we have Dr. Passan and we have everybody that we need to have to go on to, we could try to cover 3D and at least that, and perhaps launch into 4. Everybody good with that? Yeah. Yes. So to do that, Dr. Pessa, are you ready to lead us off on question 3D?
Sure.
All right, thank you.
So in terms of clearly and appropriately synthesized, I felt that it was clearly and appropriate synthesized. 52 studies were deemed medium to high confidence, and there are just some minor sort of statements in the document document that had me wondering, and again, I come more from an adverse outcome pathway than most of the people on the committee. So the first thing that struck me is that there's now evidence that perinatal exposure, and again, some of this comes from mouse studies at particularly low exposure levels in drinking water, but also extend to more recent observations on possible outcomes with healthy brain aging. And what I noticed is that there is no comments on the literature that associates arsenic exposure with neurodegenerative type health. There's a reason I sort of struck me as an adverse outcome perspective person is that the Nino et al. Paper in ACS Neuroscience not only had what I consider some of the lowest levels of exposure, but followed really sensitive outcome measures. And they did so, and this sort of brings in this idea of susceptibility. They did this study in a well-documented, well-respected model of Alzheimer's disease. These mice are asymptomatic until they're rather old. And so they exposed them to, let's see if I have the values here. I should have it here. Yeah. Essentially to 0.2 milligrams per kilogram per day of sodium arsenite from conception through 60 days of age. What was really astounding by their findings is that not only could they demonstrate cognitive impairments, I mean significant cognitive impairments at 60 days, that just don't happen in these mice until you're way beyond a year old. And so it shifted the trajectory of decrement significantly, and this was associated with about a 6 to 7-fold increase in arsenic in the brains of the mouse that were exposed relative to the same mice. They then associated or showed cause and effect that metabolic distribution of arsenic in the mice essentially was very different in the sense of accumulation in various regions of the brain and how this associated with cognitive deficits. And they actually measured the intermediates that might be responsible for this. And then I went back to the epidemiological sort of analyses, and I came to realize that, yes, many of the studies suggest that there are cognitive decrements that are associated with drinking water levels of arsenic. And then for some reason, the EPA dismisses, well, they basically say they prefer creatine-corrected urinary intake biomarkers, but that most of the studies were based on drinking water and the analysis of levels in drinking water. And I now appreciate that that has its strengths, but it doesn't tell you how arsenic is metabolized at critical stage in the perinatal period, which could be quite different from just the measurement of drinking water. There's a temporal and also a speciation issues that just isn't accounted for. I did read the cardiovascular portion, the diseases of the cardiovascular system. And I was amazed that when we talk about mechanistic observations, we tend not to relate developmental disorders with what we found in cardiovascular disorders or diseases related to arsenic. And there may be more links that a mechanistic person views that may be overinterpreted, but I don't think so. So under risk modifiers, impairments to cognition have been tightly linked to changes in redox signaling, not frank adduction of sulfhydryl groups in cells, but we know that nitric oxide and superoxide play signaling roles, and cells have generated proteins that are exquisitely sensitive to minor changes as little as 5 millivolts in redox potential. This is particularly important across the endoplasmic reticulum, where there's a 60-fold redox change, a difference that cells have been tuned to respond to changes in oxidative stress. And then I feel like the risk modifier section completely ignores the fact that there are common mechanisms with respect to redox signaling between cardiovascular and neurodevelopment and aging. And I've given some references for consideration. One of the major ways in which proteins respond to redox signaling is through changes in glutathione redox potential. And I only give one example of many that can be gleaned from the literature because I'm most familiar with it. And those are calcium release channels within the endoplasmic reticulum, which have been shown to be the target of oxidative stress and redox signaling abnormalities. And it was a surprise to me that this goes across the literature for cognition and cognitive impairments, diseases of the cardiovascular system, and I've given you reviews, but those reviews are backed up by really high quality primary journal citations. And so the question really becomes, would this be at all helpful to include either a case in point or an example where you don't have as much evidence from the epidemiological literature? Clearly, EPA's conclusions was that there's a notable uncertainty in this judgment of evidence indicates, as opposed to evidence shows, or the more So the question I have is, could such adverse outcome pathway be useful in making clearer the potential limitations with respect to adverse outcome pathways, which I think was a framework that was developed at about a time when we were getting much more information about mechanisms that contribute to disease as opposed to biomarkers that tell you the disease has already progressed. So with that, I'm going to, let's see, I think I've got the statements from the others, but if my collaborators on this question would like to proceed. I know it's much more from an epidemiological perspective than
Okay. So I can go ahead and call on them. Thank you very much, Dr. Passan. Dr. Chen.
So from epidemiology perspective, and I think the EPA sort of like separate the studies into cross-sectional study and looking at some other prospective studies. However, we actually thinking over time, there's more study in prospective cohort study come up recently. And I think EPA needs to highlight more on the cohort study because you have exposure assessment earlier than the outcome, and that should be more highlighted in the report and try to study possible windows of susceptibility given the prospective study. That is one comment. The second comment I have is the conclusions say exposure levels below 100 microgram per liter of drinking water in organic arsenic was associated with cognitive effects. While that is correct, it is really, we are talking about regulation at probably much lower than 100 microgram per liter. So it is possible for EPA to think about whether we could actually provide a little more detailed dose exposures below 100 microgram per liter, for example, below 50 or below 20 or below 10, something like that. That, especially in the US study, we do not have high exposure levels as this is part of base for future regulation. And that are two my major comments. I'll stop here. Thanks.
Okay, thank you very much. Dr. Kyrgios?
Thank you. I'll just add, as Dr. Chen mentions, there's really a growing body of evidence here on the neurodevelopmental impacts of arsenic, particularly in recent years. And many of them do employ the biomarkers like hair, urine, toenails, and blood. And many of them have looked at a suite of trace elements, including arsenic. So, I mean, the majority are on the cognitive effects. So I do think that covering this topic by the EPA is very valuable and timely. And building on another one of Dr. Chen's comments, I do agree with the premise that when you are looking at water concentrations, they are a reasonable estimate of past exposure in populations that have sort of stable chronic long-term exposure. But related to a point Dr. Chen made, we cannot look at the critical windows of exposure or evaluate windows of exposure that may be relevant or markers, susceptible windows of exposure in such studies like prenatal versus postnatal exposure, for example. And I had only one other just technical comment about the classification of the outcomes that can be considered regarding ADHD, which is typically in more of the behavioral, social, emotional category than it is cognition. But maybe other people here disagree, but that's generally how we viewed it.
So the concern is that that's a different type of outcome and can't be commingled with the others?
Yeah, I mean, it's usually just classified differently. So.
Okay, Dr. Wood.
Similar to the pregnancy outcomes, looking at figure 340, there's a lot of data here that seems to be distilled down to one study without further consideration for when I don't know if it can or not, but at least there's urinary and some drinking water that might be more informative. My other concern is that if we're going to discuss neurodevelopmental effects, can we do that in out without the context of low birth weight as well? So the two kind of go hand in hand, and how could we strengthen the argument maybe for both or for one supporting the other as critical outcomes?
Okay. Anything from the discussants? Anything further at this moment? Okay. Anything from panel members who weren't discussants on question 3D? Okay. So we have another hour of agenda time today. It's scheduled. We could consider whether to move on to question 4. And let me just ask, or we could have a summary that I'll give, which will take probably 10 minutes. And then we could adjourn and come back another day because we'll have time. So I just ask if Dr. Gribble and Dr. Pinal are feeling ready, or if you'd prefer to have the night to work. And there's no shame either way.
I can go. I don't think we're going to get to 4B within an hour. Plus 4B is long, so I don't think we should even try to do that one today. And I don't know about 4A.
I want a nap.
Okay.
People have spoken.
Okay. Well, I think you all deserve a nap given how much work you've done just in the last few weeks on this. So, okay, very good. I think there's a consensus there. We don't have to take a poll. Okay, so I'm going to try to sort of summarize what I think are some of the highlights, and I think feel free to jump in if you want to reflect something different or amend these, but these are just based on 25 pages of notes I've got from this session this afternoon. So when we look at question 1, there's in general an agreement with the question and feeling that the IRIS has been highly responsive to National Academy of Science and Engineering Medicine 2013 and 2019 reports, endorsing a focus on chronic exposures, incorporating drinking water exposure measurements as well as biomarkers of exposure. There's discussion of biases and limitations that are assessed, and those are done thoughtfully and increase confidence overall. There are, of course, always some concerns and weaknesses and some suggestions we have. There was a comment that the PBPK analysis doesn't really follow the PICO all that well, and so there might be some suggestion to do something clarifying that. Some things could be better documented, and I think we'll be highlighting those along the way. And there's some updated literature that in some cases might be helpful and informative to be completed, or perhaps commented on as to why it may not be important or relevant. There was some ambiguity pointed out in the PICO that it's not always clear why some studies may not have met the PICO criteria, and that there could be some benefit to further clarification there. And we had some discussion about that with regard to causation, dose response, specific outcomes, clear research questions, and the like. Some sense that maybe the data included since in the more recent period was highly selective without basically an explanation as to why. Then under question 2A, it was acknowledged that there's an incredible amount of work that went into this, and we commend IRIS for doing so. It was highly transparent and lends a lot of confidence overall in the conclusions that have been made. That there's high transparency. Use of the Hawk system is also notable, and that in general things can be easily viewed or looked up. The hyperlinks are helpful, the tables are helpful, and that the risk of bias methodology was well explained. There were some concerns regarding research strategies, and a specific call out to the low confidence papers as to why those in some cases were judged to be low confidence, and perhaps further transparency on that would be helpful. There were some questions from panel members on how risk of bias was assessed. This issue of covariates versus, which we further elaborated as really confounders and modifiers, how those were considered in the risk of bias. And so I think it'd be good for us to look at that section of the description of the risk of bias assessment and maybe make some specific comment as to how that might be made more clear. Then we talked about the issue of quality of sample collection analysis and how that's handled in the risk of bias assessment. And we talked about, peer review on that and whether they can go deeper into the paper, the literature, and look at the online supplements and so forth. And that was verified that yes, they do. Then we had a discussion of animal models and how they might be less sensitive to effect in cancer, but maybe not with regard to cardiovascular disease, and that they can help clarify plausibility and some of the other aspects that are typically considered in Hill criteria for epi studies. There was concern whether low confidence uninformative studies are excluded from some of the tables, and how we saw a lot of value in those tables where you can click on them and it takes you right to the information you need. And I think Dr. Karagas thought it'd be helpful if the other studies, the low confidence or uninformative, had a similar incorporation into the report. Yeah, and then there's this concern, I guess, that was raised from some of the commenters about exclusion of covariates and the question about whether they're in the causal pathway and how that is an important consideration in judging what should or should not be included as a covariate in a model. There was a statement that in many ways this is what's been done is a heroic effort. And I just want to be sure that we include those kinds of comments too, because we do want to commend EPA for the job they've done. And we covered that, the question of Wasserman. And then there was a thought about for the independence of health outcomes, and how when we sort of separate the discussion of the health outcomes, maybe we aren't always seeing about those that are associated and that one maybe affects the other. And so this is something that could be discussed more robustly. And then we clarified the internal validity idea and how that is assessed. For that, okay. So there was a question raised by Dr. Gribble about supplemental data on the BOCA paper and parameter analysis, and it was mentioned that sometimes studies that we may know of that were blinded as to analysis, or so masked studies, it's not always stated, even though we know it was, and this could lead to downgrading of the study. And short of going out and asking, it's hard to know how, if it's not stated in the paper, that the peer-reviewed publication, that EPA can really know that. So that is one of the challenges they face. And if we have information that wasn't available to EPA, that would be great if we can share that. Let's see. So with regard to question 2B, moving on to 2B, I think there was overall agreement. The presentation clearly laid out the findings and was well presented. There were then, in the words of Dr. Karagas, some suggestions for improvement. I wrote down about 10. And they're all great suggestions. Sometimes there was inconsistency between what was included in tables and what was included in the forest plots, and that went both ways. Studies in highly exposed and lower dose are more common in the US, and maybe there should be a more clear distinction made between what is a low dose study and what is a higher dose study in the presentation. And then cross-sectional studies could be more clearly described in terms of incidence, mortality, and so forth. We talked about urinary arsenic several times under a number of these different questions. In some cases, it's speciated, and we might be able to distinguish inputs from seafood, and that where possible, it's important to distinguish that. Effect modification, explain the process to identifying studies, how were data incorporated into that for question 2B. There was a question of lag time to disease and a concern that should be more clearly stated where appropriate, and particularly for question 2B, this came up. Sometimes it's hard to read my own writing. Yeah, mechanistic studies, mechanisms were sometimes superficially addressed, and there could be more clarity with regard to this and under question 2B. And then assessment of residual bias relative to dose response studies would be helpful. Other things under this notion, rather than discussing covariates, perhaps be a little bit more specific in talking about relevant confounders or effect modifiers, which has a more clear meaning in an epidemiologic framework. And then we went to question 3, 3A. Overall, there was embracing of the notion that evidence demonstrates for cardiovascular diseases that the evidence is adequately synthesized, very comprehensively described. There was a thought that some of the experimental evidence is relevant, could add strength to, and it could be included in the hazard identification. And several studies on hazard ID really were focusing on before 2019, but it was appropriate to include dose assessment studies for the 2019 and following, which was their strategy. There were some inconsistencies pointed out in figures versus tables versus text, and some specific examples that we'll be sure to highlight and share with the agency. Also typos, of course, and given the complexity of the document, I thought it was overall pretty clean, but where we find those, it's important to point those out because we want to have the document be as free of typos or inconsistencies as possible. The text handles the discussion of sensitive subpopulations pretty well, and we commended them for that. And then there was the comment, I think, that we shared with Dr. Barton's assessment that this really is a huge contribution going forward, that the focus here is on what really matters, and it goes well beyond what some of the prior considerations of inorganic arsenic have done, and so that's something that they can be commended about. And then it was added on that cardiovascular disease is such an important disease for our population that it's really crucial to identify all the environmental risk factors for that, including inorganic arsenic. With regard to diabetes in question 3B, there are a few key studies that may be missing, and one of these was pointed out as Quo 2015 et al., and it'd be good to understand why it wasn't included or suggest that it be considered for inclusion. We want to make sure that the process is transparent and there's no real thoughts that there's cherry picking going on for any nefarious purpose. We had the discussion of type 1 versus type 2 versus gestational diabetes, and the statement under 3, it wasn't really clear until we got to question or chapter 4 that section 4 that really the focus is on type 2 diabetes. So more clarity in that discussion, more transparency. The thought under diabetes in this question was that there was a good, again, a good consideration of susceptible populations and a good job accounting for and explaining sources of susceptibility. Then we talked again about urine creatinine change and the impacts of adjustment versus not adjustment, and the notion that some papers carried out the analysis both ways, and that might be useful to point to where appropriate. Question 3C then we move to, and on question 3C, the evidence was justified the assessment, and the interpretations were judged to be reasonable. There was the notion that that stillbirth and fetal loss, let's see, we should make more of a distinction between the high and low dose populations with regard to that outcome. And I think the cutoff that EPA generally used was 100 microgram per liter water concentration of arsenic, and it might be good to take that down further to 50 or perhaps even 10 in terms of looking at that outcome. We had a discussion of causal pathways, especially with low birth weight, and that perhaps there should be a deeper thought about that causal pathway and what else is in the pathway. Again, came up urinary arsenic and adjustment for consumption of seafood or speciation of the analytes as being an important thing. And then again, some new studies with mixed exposures to metals. EPA could consider looking at these in the future, or at least noting that they're there. Already talked about that one. We talked about risk modifiers for pregnancy outcomes, BMI, nutrition, SES, and there could be a more robust mention or discussion of those. And then more talk about the Kyle paper as being the one that's relied on for this outcome or set of outcomes, and that perhaps more discussion of other studies should be raised, as Kyle appears at least to perhaps be an outlier by looking at the forest plots. And then turning to 3D, Dr. Pessa had quite a detailed discussion of AOPs and sort of what that could bring to this for these particular outcomes, and argued for inclusion of animal studies in the discussion, and perhaps taking this on as a case study for outcome where there's less epi data available. And he pointed out that the AOP could be, adverse outcome pathway could be useful for determining limitations of epi data for neurological disease outcomes. And then there was the issue of cohort studies with exposure assessment prior to outcome, and thinking about those in that context. Growing evidence of neurodevelopmental and cognitive effects, studies that are using hair, toenails, blood, which aren't assessed because of the nature of the exposure assessment. So perhaps it'd be informative to have some discussion of those. And I think that those are the major points that I heard today. So I would invite anybody to comment on anything that that you may have gotten wrong or missed. And I didn't try to capture, I mean, I captured everything. I didn't try to restate everything. That would take the whole day, but there were a lot of, I think those were the key points I heard. So please go ahead, Dr. Wood.
This is actually a minor question. How do you want us to handle typos that we found? Submit them at the end, or just can we go ahead and submit them to EPA? I mean,
So I've been keeping a list of those, and I plan to hand those to Diana Wong and have her take care of it. So if that's agreeable to you.
Well, usually we put down all the editorial comment, typos, editorial comment, and we just put them all together and put an appendix at the end of the report. Okay, so you can write down all the typos you find, and we will insert into the appendix at the end of the report.
So yeah, track them and send them to the DFO.
In part of your write-up, you include them. I insert them in the report and the appendix.
Yeah. Yes, Dr. Karagas. Oh, Dr. Pessal was there too. I don't know who was first. Okay, go ahead, Dr. Pessal.
I was just wondering, I brought this up a couple of times, that there is a rich and ever increasing rich literature, in fact, in the epidemiology area about neurodegenerative disease and arsenic. Is there some a priori reason why that was not considered here as part of neurological health?
We could ask for clarification as to why. I mean, that's a legitimate question to put in your critique.
Again, from my short knowledge, I think it's a more recent literature in the last few years. So if you go to the 2019 systematic review, probably there was not much by then. And I think what, like Margaret mentioned, most of these studies have been done in the context of these mixtures panels, and so maybe not focus on arsenic per se. And many of them have cognitive function types of outcomes. And I've been reviewing that literature like in the recent months, and not so much like clinical, like real hardcore dementia or hardcore clinical outcomes. So there is some emerging evidence that is becoming important. I am not totally sure it's ready for prime time. So maybe, and between the fact that it's more recent in the most recent years, so that maybe that can help answering at least providing some initial discussion.
Thanks for the clarification.
Dr. Karagas.
Just one clarification on the charge question 3C. You mentioned about high and low dose populations. I don't think the recommendation was made to change the cut point of looking at high dose studies versus low dose at 100, but other people weigh in if that's what you heard. I think the earlier comment was that just through this section, just noting these are studies from more highly exposed populations. These are studies from, more general population exposures, or above or below 100 microgram per liter. But again, correct me if I'm wrong, but I didn't hear changing the cut point.
Right. That was attributed to Dr. Chen.
Sorry. So yeah, it's really to differentiate the high dose and low dose studies, not the cutoff change. Thank you.
Okay, so as another way to do that.
Yeah, it's not really change any cutoff. It's just to state clearly, whether the study is from high dose exposure scenario versus from like US low dose scenario. Sorry about that if I.
No, that's why we do this, right? So that we have a clear understanding of what we're talking about. Yes, Dr. Gribble.
Two other things possibly for today's summary were responses to submitted comments by public commenters. The first was the point that it's not the charge of this panel to think about beyond the human health evidence summary and any supporting toxicological evidence that's pertinent, but we're not tasked with the regulatory apparatus. That's a separate set of conversations and considerations than what we have to address. Then the second thing is several of the public commenters remarked on the rigidity and informativeness of the parameterization of EPA's risk model, especially for the meta-analysis. And we'll talk more about that with charge question 4 tomorrow. But I think it's important that we recognize that that was brought up, is people want to understand how the model is affecting the results. And my personal and professional opinion is that the model is actually very well constructed, but I think we'll talk more tomorrow about pros and cons of the current approach, but I think it's important to note it came up.
Yes, thank you for that. In my summaries, I was summarizing the afternoon, so I didn't attempt to summarize the morning. So I'm glad you brought that up, and I'd welcome anyone else to comment on the whole day if they wish, not just limit it to this afternoon. Yes, Dr. Pennell.
So this is actually an appeal for tomorrow, if I may. So for charge question 5, the statistical discussion will probably be pretty short because it's the same methodology used throughout. What would be helpful in that discussion, and I hesitate to say this because I don't want to make a lot more work for other people, is if people could, if you have the expertise, if you could comment on the appropriateness of the background incidence data that was used in the life tables, I think that'd be helpful.
Okay. Appropriateness of background data in life tables. Okay. Yeah, Dr. Chen. And then...
Yeah, I think Mike, that was alluded by Dr. and I was concerned. So actually today talked about like potentially the prevalence of cardiovascular disease in different populations as a starting point. Well, I'll talk a little more tomorrow, but so this is actually we have some considerations about really the background information about the prevalence or incidence. Actually, yeah. Thanks.
Yeah, this is great talking about tomorrow and queuing things up. I'm really glad that we're having this discussion now. Dr. Bruder, I saw you move towards that name tag, but no. Okay. Yes, Dr. Barton.
So I do think one of the things that, we've heard from the commenters as well as members of the panel, there's no question that the complexity of this assessment and the methods that are used. I mean, we heard, one suggestion that we should back off from using multiple studies and just select a single study, which was one of the critiques that was made for years of EPA IRIS assessments, was that they were choosing a single study. But I think what this reflects, and I'm trained as a toxicologist, a biochemist, even though I've done some modeling, I'm not a mathematician, I'm not a statistician. So the communications aspect of what's going on here is extremely important. And in this sense, I would sort of disagree with Dr. Gribble. You're totally right. We're not debating what the MCL should be for drinking water, but I think it's essential in this IRIS document that provides the foundations for communications that are, being driven by the analyses in this document. And I think that's an enormous challenge. I mean, it's partly because of the complexity of the analysis, and partly because we've now moved this into multiple non-cancer endpoints that have virtually not been the focus of discussion of arsenic for, decades. The discussions have been sort of locked into this endless debate over the cancer analysis. So anyway, I don't want to get on my soapbox, but I think that's a huge challenge for this assessment and for the IRIS program.
Yeah, good. Yes, Dr. Post.
I just want to say about what Dr. Gribble and Dr. Barton just said, I agree with both of them. I think what Dr. Gribble was trying to say is like if the reference dose and the slope factor are like very stringent, if that's what the science shows, and we shouldn't worry about like the regulations that'll be based on that because there's many other considerations and that's not part of our consideration here. But Dr. Barton, I also agree that, and it's going to be part of some of the charge questions, the higher numbers later. This assessment is done besides the different endpoints that he mentioned that weren't the focus for arsenic earlier. There's things about the reference dose and things like that that are different than other IRIS assessments or other risk assessments in general. And that it's going to be like a big communication project to make, because users of these numbers, programs at EPA and state program, people do not have a good it has to be very clear to someone who's not a toxicologist and epidemiologist and risk assessor what this is based on and stuff in simple terms. But I don't think Dr. Gribble was disagreeing with what they were saying different things, and I agree with both.
Yeah, so we are evaluating the document before us, and we're using the structure of the charge questions to do that with the modifications that we recommended to those charge questions. We're agnostic to the policy part of it that will come downstream because that's not our role and that's not part of this process. While while we're all aware that every time there's a risk assessment, it has incredible importance downstream in terms of protecting the human health and the environment. That considers a lot of factors that go beyond what we are considering and what this document is considering. So I think we have to feel the importance of the mission we do and the work that we're putting forward and know that it's impactful. But we are evaluating the science under the guidance of the charge questions.
Just like one more thing, so I think some of the public comments, maybe they didn't use these words, but it was sort of like saying we on the SAB and the people on IRIS who are developing this and should be really aware, like these like basically consider if really low numbers are appropriate because of the downstream implications. Maybe that's what you were trying to say, but it's really like 100% separate. That's we shouldn't even think about that. It's irrelevant to what we're doing.
Right. That's the way the procedures set up, and the way we are charged. We have a job to evaluate this document and make sure it's transparent, accurate, uses the best available science, and that it's understandable, and that's our role. So we need to make sure we stick to that role. And let me say the public commenters are welcome to say whatever they want, and that's, and their perspective is different. They might operate at different levels of this issue, and it's okay for them to bring that forward, but we have to understand what our mission is.
I wasn't trying to, I guess what I'm trying to say is there'll be opportunities for public comment later if regulations or applications of this are developed and those comments are relevant to that part, not this part.
Yeah, I mean, every FACA meeting has this as part of the process, and so there's ample opportunity for public comment at each FACA meeting, and we are appreciative of that. And as I say, they're welcome to say whatever they want as long as it's civil. Yeah, okay. So anything else before we adjourn for the day? Okay, I think then I will turn it over to the DFO, Dr. Diana Wong.
Well, we have very good discussion today and we cover a lot of charge questions. So I'm going to call recess for today and we are going to reconvene tomorrow morning at 9 o'clock. So see you all tomorrow.
Thank you. Have a wonderful evening. See you tomorrow.
Bye, thank you.